Hello. Hi. Hello, everybody. Hi, how are you guys? Is my audio video clear? Okkasari cheppandi andariki. Am I audible? Am I visible, all of you? Just give me a minute. How are you, everybody? Is everything clear? Yes. So, in session lo we will be talking about a very important chapter. And that is your alternating current. Good evening, everybody. Hi. Hi, good evening. Hi. I'm fine. Hello. Perfect. Good evening, all of you. Good evening, a very good evening from my side. Hi. Just a minute and we will start the session, okay? Okay, nimsham. Don't know what's happening today. All right. What is this? Okay. All right. Good evening, all of you. Good evening. And I hope everyone is good and fine, right? Okay. So let us start this beautiful chapter. The name of the chapter is your alternating current. Okay. Alternating current. చూసుకోండి. And అందరికి ఇదే అంటే మా లాస్ట్ చాప్టర్లో ఎలక్ట్రోడైనమిక్స్ బ్రాంచ్లో our last chapter is your alternating current. Okay. Gonad, the duration of the class will be somewhere around 4 hours. Okay, 3.5 to 4 hours expected duration ante 3.5 to 4 hours. ఇప్పుడు చూద్దాం. I don't know how long it will take. If it is getting earlier, we will be finishing earlier. లేదంటే if it is taking longer, we will be taking longer. Okay. సరే చూసుకోండి. Your electrodynamics will be completed రా. ఓకే, ఈ చాప్టర్ తోనే మీ ఎంటైర్ electrodynamics will be finished. Alternating current. చూసుకో. So what is the energy levels రా? Shall we start all of you? Start చేద్దాం. Okay. Perfect. Very good. Hi. EM completed. Okay, EM waves completed. Yeah, weightage from this chapter is at least one question, maximum 2 questions. Okay, 1 to 2 questions. Okay, on the what chapter you have your exam? Choose one more thing. We will be having a full marathon ra when it comes to your modern physics. Okay, modern physics lo meeku oka 4-5 chapters unnai ra. Okay, for all those chapters we will be completing all of them in a single day andariki, and that day is 1st of February. Okay, February the 1st. The first Sunday of your February will be our marathon for the entire modern physics. Okay, ఒకటే క్లాస్ లో you will be preparing for somewhere around 20 marks andariki. Okay, physics lo you will be having 20 marks from this chapter and you will be preparing for it in a single day, all of you. Okay, good. So session start చేసే ముందు I would like to discuss some things for you. Okay, చూసుకోండి. The students who have not taken Arjuna batch. Okay, sir, good. the students who are listening on YouTube and they are not taken the Arjuna batch, the difference between your YouTube sessions and your Arjuna batch sessions are, akkada when you join the Arjuna sessions, you will be having one-on-one interaction. One-on-one interaction ante you will be assigned with a very limited batch of the students. Aa batch nunchi when I am teaching you, okay, when I am teaching to you okay, so when I am teaching to you, I have a limited students. Ade kada? Yes. Where is it? Okay. So whatever you have doubts, whatever doubts you have, you can ask me directly over there and I will be answering your doubts by name. Ade kada? Personalized learning ante Arjuna batch is the key for your personalized learning. చూసుకోండి, prices గురించి మాట్లాడాలంటే the usual prices are this, కానీ when you're taking, the usual prices are 4,999 for your Arjuna batch because it is the Republic Days. So in Republic Day sale, your prices have been revised to 999 for your live batch and 1,999 for your live batch plus PYQ books. Okay, interested students definitely benefit from this offer. Okay, this is only for today. Today ante only for 26th of Jan. Dan tarvata the offer will be gone. Chuskondi. Okay, description section lo you have the link to register for your Arjuna batch, whoever has not registered. Ade. So with that being said, all of you, I would like to start with this beautiful chapter, alternating current. Okay, yes. ఏదైనా డౌట్స్ ఉంటే అడగండి. సో వాట్ ఆర్ ద ప్రీరిక్విజిట్స్? ప్రీరిక్విజిట్స్ ఏం కావాలి చూసుకోండి. ఈ చాప్టర్ ని స్టడీ చేయడానికి యు మస్ట్ బి గుడ్ విత్ యువర్ ఎలక్ట్రోమాగ్నెటిక్ ఇండక్షన్. అదే, ఇఫ్ యువర్ ఈఎంఐ ఇస్ గుడ్, that means the foundation for this chapter will be good ra andariki. Okay sir, what is useful for our EMI? Chuskondi andariki. I am trying to tell you once again, try to understand. You have inductor kada? Yes. So this was your inductor. What is the function of this inductor, sir? This inductor has a single function ra, okate function. Emuntundante, you simply connect it with a battery. Okay, try to understand everybody. Ledante you can also join a resistor ra, chinna resistor join cheddam chuskondi. So ide, this is my resistor, this is my inductor. Eppudu emaitidi ante, due to this resistor there will be current in the circuit. Ade kada? Yes. Kani this inductor does not like the change in the current. You are understanding? Yes. Ante if you are drastically increasing the current, inductor will oppose. Ade kada? Yes. So if you are drastically increasing the current, inductor will say, hey, wait, I am the bodyguard over here. Whoever is entering must ask me ra. Okay? Hey, what's going on in the chat section ra? Edaina good. So inductor will say, whatever current you are flowing ra, stop. So I will not let you come once in a while. Don't come all of you together. Ante koncham vachindi. So it will slowly allow the small current to increase, right? Does not like the change. Ade kada? Yes, that is the principle that we have discussed. What about the potential difference across the inductor, sir? That is minus L times of di upon dt. Idigo ide gurtu pettukondi, because this will be required to you, all of you. అర్థమైంది సరే. పర్ఫెక్ట్. సో ఇప్పుడు లెట్ us స్టార్ట్ అవర్ చాప్టర్ రా. ఓకే, ఆల్టర్నేటింగ్ కరెంట్ అంటే ఏంటి సార్? in your alternating current, when it is about direct current, చూసుకోండి అందరికి, when it's a direct current DC ఉంటే మీ వైర్ నుంచి ఒక సింగిల్ డైరెక్షన్ లో కరెంట్ ఫ్లో అవుతుంది. అదే కదా, yes, in a single direction. Ante if this is your place A, this is your place B ra, the current should actually start from place A and should travel to the place B until this is your direct current. కానీ మీ alternating current లో ఏమైతుంది అంటే the current లేదా the charge లేదా the electrons or the protons, they do not flow ra, they do not flow. చూసుకోండి, అంటే ఇదే మీ ప్లేస్ A ఉంటే your place B is there రా, చూసుకోండి there are charged particles అంటే electrons కదా, yes చూసుకోండి ఈ మొత్తం electrons ని you give a single type of motion అంటే they oscillate back and forth. అదే this is known as your alternating current. అందరికి చూసుకోండి, you are understanding? Okay, sir, good evening everybody, good evening, very good evening. చూసుకోండి, so in your alternating current the charges simply oscillate back and forth. And what is current ra? Motion of the charged particles. ఇప్పుడు there is no limitation అంటే the motion should be straight లేదా the motion should be back and forth, nothing at all. అంటే if at all your charges are moving, we will simply say the current is there. అదే కదా, yes, very good, very good. So let us talk about the types of current ra, types of alternating current. And there are some variations kada, yes. So your alternating current can be differentiated by the following. చూసుకోండి అందరికి, కానీ మొదటిగా we will talk about the characteristics. చూసుకోండి, your characteristics include your alternating current starts and it attains a maximum value ra, దాని తర్వాత it becomes zero లేదా if it's not becoming zero it attains a minimum value. చూసుకోండి, alternating current is a bounded current ra, AC alternating current is a bounded current. అంటే ఏంటి bounded అంటే ఏంటి sir? That will have a maximum value I max and it will have a minimum value I minimum. అదే ఇప్పుడు the current simply oscillates between this maximum and minimum value. If you want it to oscillate, it will oscillate. లేదంటే it will just take the maximum minimum, maximum minimum, maximum minimum. So graph గురించి చెప్పాలంటే you can understand, okay, the first type of graph is this. అంటే it is simply taking your maximum value, immediately after your maximum value your alternating current is jumping to your minimum value. ఎక్కడి నుంచి మళ్ళీ ఒక్కసారి maximum value, దాని తర్వాత మళ్ళీ ఒకసారి మినిమం వాల్యూ. చూసుకోండి, ఈ కేసులో యువర్ ఆల్టర్నేట్ కరెంట్ ఇస్ సింప్లీ ఆసిలేటింగ్ బిట్వీన్ మాక్సిమం మినిమం కదా, ఎస్ ఎస్. సో దిస్ ఈస్ ద కండిషన్ ఆఫ్ యువర్ ఆల్టర్నేటింగ్ కరెంట్. చూసుకోండి, you're understanding? Yes, it is my time and ide ante my current axis. So this is one of the types of alternating current where it is taking the boundary conditions. Boundary conditions ante enti ra? Minimum maximum. It is not achieving any middle value ra. Intermediate values have not been achieved. Ade kada, yes. The second type of the current will be like this. Chuskondi andariki, ante your current is taking maxima and your current is taking minima. Andariki chuskondi. So this is the maximum value, దాని తర్వాత it is decreasing to minimum, మళ్ళీ ఒకసారి maximum and so on so forth. Are you able to understand? Yes. Again a minimum value, then we can differentiate it. All of you try to understand it. Okay, try to understand. And lastly, and this is the most favorable case, all of you చూడండి, this is the graph. అంటే ఈ గ్రాఫ్ లో your current is varying sinusoidally. అంటే your current I on y axis, your time on x axis. ఇదే కదా, yes. So your current will have the equation I is equals to I naught sin of omega t. చూసుకోండి, I naught అంటే the peak value of the current, peak value of the current. ఇదే కదా, yes. So this is the peak value of the current. చూసుకోండి, ఇదే. And this is also the peak value కానీ negative value. So this value becomes I naught and it is minus I naught, right? ఇక్కడ కూడా the same thing. You apply the same thing over here also. This becomes your peak value I naught and this becomes your peak value in the negative sign అంటే minus I naught. చూసుకోండి. Are you able to understand? The graphs of your alternating current simply oscillate between two values ra. The first one is the maximum value, the second one is your minimum value. Ante kada? Yes. Yes, Ganesh, yes. Graphs also matter a lot. Okay, graphs also matter a lot. Chuskondi. Let me tell you a little more conceptual clarity ra andariki. The question is the following graph graph తీసుకోండి అందరికి లేదా which of the following is alternating currents, okay, లేదా which of following graphs represent pure alternating current. First one is this. I should not say this. Okay, your second option is this. Andariki jagrataga cheppandi ra. Okay, this is my value. Idena x axis, idena y axis. Y axis ra, y axis, and your current is oscillating somewhere here. Okay, ide me current and this is your time. Cheppandi. What is the difference between the two ra? Modatiga ade cheppandi naku. What is the difference between the two graphs? First, you should note the difference, then and only then you can answer the question, kada? So first tell me what is the difference between the two graphs, andariki. What is the difference, Ra? Okay, JE paper, what? What with JE paper? You want me to discuss JE paper? Okay. Oh. Okay, origin is different. Ante, చూసుకోండి. When you talk about this case, all of you, it's a very conceptual thing, okay? It's a very conceptual thing. చూసుకో. ఈ కేసులో this is your x-axis, this is your y-axis కదా? Yes. What is the difference అంటే your graph is symmetric about x-axis. ఇదే కదా? ఇదే మీ x-axis, it is symmetric about x-axis. కానీ ఈ కేసులో this is your x-axis, this graph is not symmetric about x-axis. అదే కదా? That is the biggest thing. చూడండి, ఎప్పుడు కూడా you are talking about the alternating current, your graph, this is a conceptual clarity. Okay, మీ graph x-axis respect no, your graph should be symmetric. About what, Ra? About x-axis. What if it's not symmetric, Ra? Is this not alternating current? Is this alternating current or not? The answer is, it is alternating current. Yes, it is. Kani, not pure alternating current. Ante, ee case lo, it is a combination of your alternating current plus your direct current. Chuskondi. You are understanding? Just remember these things, Ra. Okay? If it is lifted up, leda if it is lifted down. Ee mottam cases lo, you will simply say that your graph is a combination of alternating and direct current. Chuskondi. It's not symmetric with respect to x-axis kada? Yes. We will simply say both are sinusoidal ra. Idi kuda sinusoidal, idi kuda sinusoidal. Kani sinusoidal is not the parameter with which we will be judging about the alternating current or not. ఒకటే పారామీటర్ ఏంటంటే your graph must be symmetric with respect to x-axis. Symmetric with respect to x-axis అంటే ఒకటే గ్రాఫ్ ఉండాలి. ఆ గ్రాఫ్ కూడా it should cut the x-axis and it should be symmetric అంటే whatever the graph is above, ఏదైనా పైనకి ఉంటే అదే the same should be in the downward direction also. You are understanding? సరే, ఓకే, పర్ఫెక్ట్. ఇప్పుడు చూడండి, let's talk about the types of currents ra. Okay, so the general equation of your current in your alternating current will be given as I equals to I naught times of sine of omega t. చూసుకోండి, ఇదిగో అందరికి the first terminology I will be explaining is your peak current. Okay, the chapter starts from here ra. Peak current గురించి చెప్పాలంటే your peak current IP is nothing but the I naught value ra. ఇదిగో, you are understanding? That is your peak current. What about the next type ra? The next type is your average current. Andariki ide kada? Yes, the next type is your average current. Chudandi, eppudu when you talk about the average current, we discussed about the average speed, we discussed about the average acceleration, ade kada? Yes. So average speed lo what we were saying ra, మీ average speed అంటే total displacement upon total time, ఇదే కదా? Average speed is total displacement upon total time. చూసుకోండి రా, let me just go quickly. Your average speed is equals to, గుర్తుందా, it is total distance రా, total distance upon total time. Distance అంటే ఏంటి రా, ఇప్పుడు ఇంటిగ్రేట్ చేసుకో. Distance అంటే ఇంటిగ్రల్ vdt కదా, divided by ఇంటిగ్రల్ dt. అదే, this is your average speed. Similarly, అలాగే ఇక్కడ కూడా చెప్పండి, the same thing రా, your average current is equals to your total charge అంటే ఇంటెగ్రల్ I dt. The limits are t1 నుంచి t2 వరకు రా, divided by the same limits t1 to t2 integral of dt. ఇదిగో, this is a formula for your average current. అందరికి this is a formula for your average current, అదే కదా? Yes. కానీ there are again some important topics that I want you to note it down, ra. All of you, there are again some important topics. What are the important topics? The first one is, if your current is varying with respect to sine leda cos. If your current is varying with respect to sine or cos, ante me I is equals to I naught sine of something, okay, something, లేదా మీ I is equals to I naught cos of something. ఇదిగో చూసుకోండి, the first thing is the average values. Okay, చూసుకోండి, average values of sine and cos, ఇదే కదా, sine and cos over interval కూడా గుర్తుపెట్టుకోండి రా. ఇంటర్వల్ అంటే ఇది చాలా చాలా ఇంపార్టెంట్. ఓకే, the interval is 0 to 2pi రా, is equals to 0. అంటే when I am telling you, should I give you an example? Let us say, let us take all the examples later ra. Ippudu let us talk about your RMS current. Andariki, your RMS current, third type is your RMS current. What do you mean by RMS current, sir? Your RMS current, IRMS is equals to the same thing. మొదటిగా రూట్ తీసుకోండి, రూట్ లో మీన్ కూడా స్క్వేర్ చేసిన తర్వాత, అదే కదా? Yes. So you can simply say it is root of integral of I square dt ra, divided by integral dt. The limits should be same, t1 నుంచి t2 వరకు, ఇదే కదా? Here also from t1 to t2. ఇదిగో, this is your RMS current. కానీ RMS current కూడా it comes with a slight moderations అంటే ఏంటి రా? చూసుకో. So you can simply say here also, ఇక్కడ కూడా, if your current I is equals to I naught sine of something, లేదా I is equals to I naught cos of something. Understand రా, మీ చాప్టర్లో 99% కేసెస్లో we will be talking about the current format in this అంటే your I naught sin లేదా I naught cos చూసుకోండి. ఇదే అంటే మీ సైనోసాయిడల్ కర్వ్ కదా. ఎస్ సరే. సో your current is like this రా. Here you can simply say when you are squaring it, square చేస్తుంది కదా. So when you are squaring it, I naught kuda it is getting squared ra. At the same time, sin is also getting squared, sin squared, sin squared, sin squared. Here we are talking about sin and cos average values kada. Ekkada vachi we will be talking about average values of sin square and cos square. Chuskondi. So you can simply say average value of sin square theta, whatever it is ra, and at the same time average value of cos square theta is half 1/2 idigo over a certain interval. Certain interval ante the same thing ra, in the interval 0 to 2 pi ide kada. Yes, limits kuda kurtu pettukondi andariki. Limits are the most important game changers ide kada. Yes, so ippudu let us talk about your questions ante enti ra. The first question looks something like this. Okay, find peak, comma, average and RMS currents. For the following. ఇదే కదా. చూసుకోండి. If I only give you the equation, the question will be incomplete ra. Ante chusko. This is my equation. I is equals to I naught, not I naught ra. Okay, let us say 2 sin of 40. ఇప్పుడు క్యాల్కులేట్ చేసుకోండి. అంటే this question is incomplete. ఎందుకు incomplete sir? Because ఈ question లో you don't have the limits. Are you understanding? If the limits are in such a way that the sine graph is getting completed, ante enti ra, the limits must be from 0 to 2 pi, ledante the limits must be from 2 pi to 4 pi, ledante you are try to understand there should be a gap of 2 pi ra, 2 pi gap undali. Then and only then you can simply talk about the average values ra. So now I'm giving you the limits in such a way that from t equals to 0 to t equals to pi by 2. Ide kada? Yes. This is an important limit that I have given to you. Limits kuda gurtu pettukondi. Limits keep significance. What's your doubt ra? Cheppu. What is your doubt? The doubt must be relevant. The doubt must be valid. Okay, if you are asking, sir, where are you from and all these things, okay, it should be relevant. It should be valid and relevant. Relevant ante it should be relevant to your syllabus. All of you attempt this question ra. Andariki cheppandi what is the correct answer for this. Okay, let us see who can tell the answer. Naku peak value, average value and RMS values kavali. What electronic process typically converts the signal in graph 1 into the signal shown in graph 2? What is graph 1 and graph 2 ra? Peak current is 2 ampere. Good. In case you can simply say your peak current is equals to 2 ampere. Point number 1. Ippudu when you are talking about the average current ra, I average, it should be total integral of your current. Current ante enti ra? Integral of I dt divided by total time interval dt. Ide kada. Kani keep the limits in mind. Okay, keep the limits in mind. Andariki hi honey, hi. What are the limits, sir? The limits are from 0 to pi by 4. Ide kada? Yes. 0 to pi by 4. Kani, when you try to substitute these limits in this equation ra, cheppu. Your 0 ante enti ra? 4 into omega t kada. I want the value of sine of whatever is there ra inside. Inside is omega t, simply omega t kada ante 4t. So ఇప్పుడు I have to calculate this value of 4t ra. మొదటిగా you substitute the value of time as 0 seconds. So it comes out to be 4 into 0 అంటే 0. ఇదే కదా? Yes. దాని తర్వాత when you're talking about the another time అంటే pi by 2 ra. 4 into t అంటే 4 into pi by 2. That means simply equals to 2 pi. That means I want the average of sine from 0 to 2 pi. ఇదే కదా? Yes. That is 0. చూసుకోండి. Here I have written it. అంటే your average of sine from 0 to 2 pi is simply equals to 0. That means this average is simply equals to 0. అంటే your average current is 0. అదే కదా? Yes. What about your RMS current రా? చెప్పండి ఒకసారి. Sir, your RMS current, IRMS. Formula చెప్పు ఒకసారి. Your RMS current is equals to integral I square dt upon integral dt. అంటే ఏంటి రా? That is simply equals to integral of I0 sine of omega t whole squared divided by integral dt. ఇదే కదా? 0 to pi by 4. ఇక్కడ కూడా 0 to pi by 4 రా. అందరికి చూసుకోండి. I hope it is able to understand. Okay. Yes. What is the value, sir? So can I simply say, చూసుకోండి రా, I0 అంటే కాన్స్టెంట్ కదా, take it out. So it comes out to be I0 squared integral of sine squared omega t divided by integral of dt. చూసుకో, this entire quantity అందరికి ఇది ఈ మొత్తం క్వాంటిటీని we will calling it as the average value of sine square. The average value of sine square రా. What is the value of the average value of sine square and cos square రా? Half అంటే ఈ మొత్తం కి ప్లేస్ లో you will simply be writing it as I0 squared into half. అంటే you can simply say your RMS current root in root ra. Hey, I'm sorry, hey, all of you, it should be in root. Okay, it should be in root ikkada kuda it should be in the root. So ide mee RMS current ra andariki ide kada. Yes. So your RMS current is equals to square root of I0 square I0 into root 2 ade. So that means your RMS current in this question should be equals to your IRMS is equals to peak current and enti ra 2 into root 2 ampere. Idigo. So this is your RMS current. Kani jagrataga vinandi ra, if at all you have been given your current in only sine and cos, then and only then you can talk about these things. Ledante you should be considering integration. That is not there for you ra. It is usually asked for JEE students. Okay, so they are idiots. They do some integrations over there, but we don't have to do anything over here. Okay, you don't have to do. We have the simple methods. These simple methods to we have to attempt the question, get the marks, become a doctor, and do my free treatment. Ade kada? Yes. Good. Very good. ఇప్పుడు let us talk about your AC voltage. Voltage అంటే ఏంటిరా? Your electromagnetic induction లో, do you remember if we change the angle between your area and your magnetic field? Okay, the angle between your area and the magnetic field ante, if you are simply saying that your magnetic field is like this ra, చూసుకోండి అందరికి జాగ్రత్తగా వినండి all of you. Okay, this is your magnetic field B bar. ఇదే కదా? Yes. This is the magnetic field B bar in the right side ra. మొదటిగా my loop అంటే తెలుసా? loop అంటే the closed figure made by a wire. It could be a rectangle, it could be a triangle, it could be a square, లేదా circle, whatever you want, you can take it over here. ఇదే కదా? Yes. So you can simply say this is your loop. అందరికి చూసుకోండి, this is your loop. అదే కదా? Yes. Where is the area vector pointing? ఈ క్వశ్చన్ లో మీ ఏరియా వెక్టర్ is exactly aligned to your magnetic field. అదే కదా? Yes. Correct. But as you are changing it, ante as you are rotating this loop ra, so this was my initial loop andariki. Ante area vector towards the right side, magnetic field కూడా రైట్ సైడ్ లో ఉంటుంది అదే కదా. నౌ యాజ్ యు ఆర్ రొటేటింగ్ ఇట్ చూసుకో కొంచెం సమయం తర్వాత ద ఏరియా వెక్టర్ హ్యాస్ చేంజ్ టు దట్ డైరెక్షన్. కానీ వాట్ అబౌట్ యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ రా, యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ ఇస్ స్టిల్ ఇన్ ద సేమ్ డైరెక్షన్ అంటే రైట్ సైడ్ లో అదే కదా. ఎస్, సో దాట్ మీన్స్ యాజ్ యు ఆర్ చేంజింగ్ ద ఏరియా, rotating the area, okay, not changing the area, I'm sorry, as you are rotating the area the angle is changing ante మీ total flux kuda it is varying అదే కదా. yes, అంటే మొదటిగా when you are writing the equation of your flux is simply equals to b bar dot a bar అంటే it is equals to b into a into cos theta. Initially your theta value was 0 ra, ఎందుకంటే your area to the right and your magnetic field to the right అదే కదా. yes, now what you are doing is your magnetic field is to the right కానీ your area it is changing the angle, అంటే తెలుసా, something like this. so therefore we will be introducing a new terminology cos theta into the flux అదే కదా. what is the value of theta sir? theta is the angle change ra, చూసుకోండి. so if omega is the angular speed ra, omega angular speed unte t time tarvata you will be getting your angular displacement theta ante మీ theta ki value is nothing but theta is equals to omega into t అదే కదా. yes, hey lift shift చెప్పు what is the flux ra. so ఇక్కడ నుంచి మీ flux is equals to b into a into cos of omega into t ఇదే కదా. yes, this is your flux కానీ we have only a single turn ra. if there are multiple turns అంటే second turn ఇదే నా third turn, నా fourth turn, నా fifth turn, ఇదే sixth turn and so on so forth. let us say there are total n turns ra. ఇప్పుడు చెప్పు ఒక్కసారి, can I simply say that your flux ఈ కేసులో your flux is equals to n times ఈ మొత్తం flux రా అంటే n times of b into a into cos of omega into t ఇదే కదా. very good. that means your total flux has been changed to phi is equals to nba cos of omega into t. ఇప్పుడు చెప్పండి. now what I have to talk about is as your flux is changing, Faraday's law ra, EMI law, you have Faraday's law. what does it say? Your Faraday's law simply says that your induced EMF E is equals to minus d phi upon dt ఇదే కదా. అంటే first differentiate then add a negative sign. do the same thing here also ra. చెప్పు your d phi by dt value ఏంటి రా, d phi by dt is equals to nba constant కదా. yes, so nba will be remaining constant. ఇప్పుడు ఈ cos omega t ని differentiate చేసుకోండి. when you are differentiating cos omega t you get omega multiplied by the derivative of cos is minus sign, okay, minus sign. the derivative of cos omega is minus sign అంటే this minus sign I am writing here రా, చూసుకోండి. అంటే this is your d phi by dt. that means your EMF is negative of this quantity ra. ante your EMF induced is equals to simply nba omega, the derivative of cos is sine of omega into t. చూసుకోండి. this is your total EMF. you are understanding? ఇదే అంటే మీ total EMF రా. so for the entire quantity అంటే for this quantity I can simply write sir your EMF E is nothing but E naught into sine of omega into t. చూసుకోండి మీ E naught value అంటే ఇదే nba omega. all of them they are constant. n అంటే number of turns constant. ఈ కేసులో your magnetic field is also constant రా. area is also constant. okay, yes, Sudhakar, it will be available soon. okay, and your EMF is generated this way. చూసుకో. you are understanding all of it? you are understanding? అంటే if I connect this loop somehow if I connect this loop, it's a rotating loop kada. so this rotating loop behaves as a battery అంటే తెలుసా. now what we'll do is we'll simply put this entire system in a box. okay, we will simply put this entire system in a box and ee box ni we will be calling it as AC source. What are we calling? We are calling this as AC source ra. Ee mottam system ni vinandi andariki, all of you try to understand. Try to understand. This entire setup, we are putting in a box, okay? We don't want this complexity ra. Ante I want something. What is there in the box, sir? I don't know what is there. Car. Me car. Do you know what is the engine made up of? Do you know what the tires are made up of? Kani, when you see it, you see a beautiful car kada. Yes, to reduce the complexity, we will be putting it in a box ra. Chuskondi, okay? So ee box ni, this box is there ra, okay? This box is there. Ee box lo there are some magnetic fields, and ee magnetic field nunchi there is this loop that is rotating at an angular speed omega. Andariki chuskondi. Are you understanding? Ippudu I will not take these things ra, okay? I'll simply say this is a box, and I'll simply write this symbol ante we will simply be calling it as AC source, okay? Ekkadi nunchi we will be calling it as AC source. That means it is generating the voltage ante current. How is it generating? Same process. So you see your windmills, what are they doing? Rotating. Same thing, rotating in the magnetic field. Current is generated. Ade kada? Right. Your hydro power plant is there. Your nuclear power plant is there. In mottam places lo, what happens is you have a turbine ra, and that turbine rotates in an external magnetic field. Ade. So rotation, flux change ante EMF induced ante current induced. Ade kada? Yes. Vinandi. Right. Very good. So ippudu once we are done with your AC source ra, we will connect it with your circuit elements. Andariki chuskondi. So now you are connecting your AC source with various circuit elements ra. Idigo circuit elements ante moodu na information lo unte circuit elements gurinchi maatladalante there are only 3 circuit elements. Cheppandi, what are the circuit elements ra? What are the circuit elements? The first one is your resistor. Ide kada? Yes. Dan tarvata what do you have? You have your capacitor. Oh, nice. And lastly, cheppu. Resistor, capacitor, and ide kada? Ayipoyindi? No re. It's not completed yet. Your resistor is there, your capacitor is there, and your inductor. Correct. Your inductor is there. Idigo. So ippudu for the next 1.5 hour, ikkadi nunchi for the next 1.5 hour, my only target leda my only goal will be to analyze how these circuit elements oppose leda support, whatever they will do, okay? Ekkadi nunchi for the next 1.5 hour, I will be focusing my entire attention on these 3. Ante let us take combinations ante modatiga we will take one by one, then we will try to combine any 2 of them, and then we will try to combine all 3 of them. Ade kada? Yes. Good. Oh, nice. Siri, thank you so much. Hey, half kada? Half. So ikkadi nunchi it is half ray. Where is it? Yes, into half kada? So there is this calculation mistake, all of you. Hey, the root of half ante enti ra? Thank you so much for clarifying ra. Okay, it's gone. So your current RMS is I0 square into half, root of half into root of half. Ide kada? Yes. So it is I0 into 1 upon root 2, that is equals to I0 divided by root 2. I0 value is 2, root 2 is root 2, ante root 2 ampere is your current. Ide kada? Yes. There was some student in the chat section who was telling me 2 root 2, I got into the flow, and this is the result. Chuskondi. Sare, ante kada? Yes. So we will first talk about your resistor, then your capacitor, and dan tarvata we will talk about your inductor. Ade kada? Yes. So we will start with your resistor. Andariki chuskondi. First of all, let us talk about mathematically ra. Dan tarvata we will go and we will try to analyze it in a realistic field of view. Okay, చూసుకోండి అందరికి. So You can simply say, hey, all of you, చూసుకోండి, your first case is లేదా your first circuit is pure resistive circuit. ఇదే కదా? Yes, ఇదే మీ first circuit రా. This is your pure resistive circuit. The biggest problem is I do not make. Okay. Sir, pure resistive circuit lo, what you have is you have a battery, EMF. What EMF ra? AC source. గుర్తుందా? ఇదే చూసుకో. What did I say? ఈ మొత్తం కాంప్లెక్స్ scenario we will be converting it simply into a circle and this curve. We will calling it an AC source ra. Whenever I am telling AC source, you understand everything is going on into it. Okay? Everything అందరికి. Good. So let us talk about pure resistive circuit ra. Connected across AC kada? Yes. Me pure resistive circuit, it is connected across your AC. AC ante this is your potential ra. Ante this is your AC. Ee AC nunchi you are getting EMF leda voltage ra. Voltage. What is the value of that voltage, sir? Sir, V is equals to V0 into sine of omega into T. Ide kada? Yes. Chuskondi. So ఇప్పుడు what I am doing is I am connecting this with a resistor, a simple resistor. చూసుకోండి అందరికి. Try to understand. Okay? Yes. Clubbing chapters will be available soon, ra. Soon. Okay? Clubbing chapters will be available soon. చూసుకో. మీ resistor R ఉంటే what you will say, ra, sir? We will simply say, sir, your current formula చెప్పండి. ఈ కేసులో your Ohm's law will be useful కదా? Yes. So your Ohm's law simply says your I is equals to V upon R. అంటే V వాల్యూ చెప్పు ఒక్కసారి. It is V0 times of sine of omega into T divided by R. అంటే V0 upon R multiplied by sine of omega into T. This is the value of your current. అందరికి the same thing ఎక్కడ వచ్చి you simply say, yes, don't go further. చూసుకో. So your current is equals to simply ఈ మొత్తం quantity ని రా, we will call it as I0. Okay? I0. Substitute రా. మీ current is equals to I0 into sine of omega into T. ఇదే కదా? So this is your current. So when it comes to pure resistive circuit, చూసుకోండి. I am telling you some things. Okay? Some things. చూసుకో. You are dividing this voltage by resistance kada? Yes. So your I0 value is nothing but, sir, V0 upon R. Whatever you are dividing, andariki jagrataga vinandi. Okay, I will be calling it once again. Whatever you are dividing V0 you are dividing V0 with R kada. ఈ కేసులో మీ R అంటే రెసిస్టెన్స్. చూసుకోండి, రెసిస్టెన్స్ అంటే ఏంటిరా? రెసిస్టెన్స్ అంటే this resistor will not, లేదా it will create some obstacles in the current kada? Yes, the same. It will create some obstacles. So when you talk about the remaining two ra, ఈ మిగతా రెండు గురించి మాట్లాడాలంటే the same thing we have to observe about their resistances. So when we were talking about your resistor ra, your resistance is simply equals to R. ఇదే కదా? Yes. ఇప్పుడు కెపాసిటర్ గురించి మాట్లాడుతాం. చూసుకోండి అందరికి. Let us talk about your capacitor. అంటే you are connecting your capacitor across an AC voltage. AC source అంటే అదేరా. మళ్ళీ చెప్తున్నాను అందరికి. You must keep it in your mind. Whenever I am writing this symbol and this curve అంటే ఏంటిరా? ఈ బాక్స్ లో you have a magnetic field and you have a loop that is continuously rotating. అదే కదా? And it is creating your alternating voltage లేదా your alternating current. అందరికి అర్థమైంది? Yes. So now what you can say is you can simply try to visualize ra. ఇదే this is my alternating source కదా? Yes. ఈ alternating source తోనే I am connecting a capacitor. Okay? Capacitor అంటే this. చూసుకోండి అందరికి. ఇప్పుడు let us say the voltage V is equals to V0 sine of omega into t. ఇదే కదా? Yes. Let us see the capacitance is C అంటే your capacitance రా అందరికి. ఇప్పుడు what will happen is at a random time రా, ఒక random time తీసుకున్నాను చూసుకోండి అందరికి. So let us say at a random time the charge will be plus q and the charge will be minus q ra. These charges are continuously variable, they are changing. అంతే కదా? Sometimes plus q minus q, minus q plus q, plus q minus q, minus q plus q, and so on. Continuously changing the charges. ఇప్పుడు what you will write is the potential difference across this source ra should be equals to the potential difference across this source kada? Yes. Potential difference across this source is nothing but V0 into sine of omega into t must be equals to potential difference. Cheppu, what is the formula for your capacitance, charge and potential sir? Q is equals to CV. Kani V is equals to Q is equals to CV sir. V is equals to Q upon C. Ide kada? Chala important. Very important. Okay? Very, very important. Andariki. So your voltage is nothing but Q upon C. This is your voltage. Q upon C. Yes. Send it that side. Andariki. Send it that side. So you can simply say your charge Q is equals to C into V0 into sine of omega into t. This is the charge that will be deposited on the plates of capacitors. Ade kada? Yes. Very good. ఇప్పుడు what you are trying to find is current రా, నాకు కరెంట్ కావాలి కానీ చార్జ్ వాల్యూ ఉంది నా దగ్గర. సో ఇప్పుడు ఏం చేయాలంటే డిఫరెన్షియేట్. అదే I is equals to dq upon dt. Differentiate sir. Your I is equals to dq upon dt. ఇదే కదా? ఈ ఫార్ములాలో సబ్స్టిట్యూట్ చేసుకోండి రా q వాల్యూ d upon dt ఆఫ్ మొత్తం q అంటే ఏంటిరా? C v0 sin of omega into t. అదే కదా? ఎస్. C v0 కాన్స్టెంట్ ఉంటే బయటికి తీసుకోండి అందరికి. సో యూ కెన్ సింప్లీ సే C into v0 into differentiation of sin cos కదా? ఎస్. అండ్ దీంట్లో కూడా యూ హ్యావ్ ఒమేగా అంటే ఒమేగాని కూడా బయటికి తీసుకోండి. సో C v0 omega cos of omega into t. చూసుకోండి, దిస్ ఈజ్ యువర్ కరెంట్ రా అందరికి. కానీ లెట్ us compare the formats అంటే మీ పొటెన్షియల్ ఇట్ ఈస్ చేంజింగ్ విత్ సైన్ కానీ యువర్ కరెంట్ ఈస్ చేంజింగ్ విత్ కాస్ కదా. లెట్ us bring it in the same form రా. Let us bring it in the same form అంటే your cos theta చూసుకోండి. మీ cos theta is nothing but there is a trigonometric formula sine of theta plus 90 degree. ఇదే కదా? Yes. So instead of this cos theta, it is C v0 into omega into, instead of cos theta ra, substitute sine of omega t plus 90 అంటే ఏంటి రా? pi by 2. So this is your current. అంటే I is equals to V0 into CV kada? V0 into C omega into sine of omega t plus pi by 2. ఇది ఇప్పుడు the question is when the circuit was resistive circuit రా, మీ resistive circuit లో we have something known as resistance కదా? చూసుకోండి. ఈ కేసులో I've told you, what did I tell you రా? అందరికి చెప్పండి. So in your resistive circuit చూసుకోండి, what did I say? Your peak current I0 is V0 upon something. ఈ something అంటే your resistor కదా? Yes. So we have to bring everything అంటే your I0 should be equals to V0 upon something రా. Something. మీ resistance కేసులో this something is R కదా? Yes. కానీ when it comes to your capacitors రా, చూసుకోండి, it is N to CV. So what we will do? We will smartly arrange ra. Basic mathematics completed kada. Let us apply the same thing. Ante your I is equals to V0 upon something kada. So C omega ni I have to adjust. Ante it becomes 1 upon C into omega. Choose ko. Ippudu 1 upon C omega is nothing but C omega only. Ante this and this are same only. Ante this becomes a resistance only. Resistance of your capacitor. Resistance. We don't call it resistor. Okay. We don't call it resistor, we call it reactance. Okay, ఈ కేసులో మీ వాల్యూ 1 upon c into omega అంటే it is the reactance. Reactance గుర్తుపెట్టుకోండి. Reactance అంటే similar like your resistor రా, కానీ your resistor has a specific word resistance కదా, కాబట్టి ఈ కేసులో we will be calling it as your reactance. కానీ కెపాసిటర్ గురించి because it is due to your capacitor, we will be calling it as capacitive reactance. What will be calling? We will be calling it as capacitive reactance. We will simply say it is capacitive reactance. ikkad nunchi whenever you are asked about capacitive reactance, గుర్తుపెట్టుకోండి, the value is nothing but 1 upon omega into c. అదే కదా, the duration of the class is somewhere around 4 hours. Okay, 4 hours. Somewhere around 11 p.m. ra. Okay, 11. Approx 11. Approx. Right, we will be starting early with your wave optics. Okay, ఒకసారి your wave optics has also been completed అంటే your oscillations, your mechanics, there is one chapter left, fluids, and your electrodynamics. 3 branches are completed. దాని తర్వాత the 4th branch will be your modern physics. It will be completed in a single day. Last branch will be remaining is heat. అదే heat. I have completed mechanics. I have completed electrodynamics. I have completed geometrical optics. అదే కదా? Yes, geometrical optics also. It's a branch. It's not a chapter. It's a branch. Okay. Yes. So your wave optics also completed ante your oscillations and waves completed. 4 branches are completed. Remaining is your modern physics and your thermal physics. Thermal physics lo you have 3 chapters, modern physics lo you have 4 chapters. It will be completed by your February 1st week లేదా 2nd week. అదే కదా? Yes. చూసుకోండి అందరికి. ఈ కేసులో your 1 upon omega c అంటే your capacitive reactance. Capacitive reactance. అదే కదా? Yes. Yes. It will be out. Don't worry. We will make a video on limited chapters also. అంటే when you have a simple capacitor connector చూసుకోండి అందరికి. What are you doing, sir? Villain, hey, చూసుకో. So in this case you can simply say plus q charge is there, ikkada minus q, your v is equals to v naught into sin of omega t. కరెంట్ గురించి చెప్పాను ఒక్కసారి. These values, these formulas must be on your fingertips అందరికి. alternating current లో ఇదే. This is the biggest thing. Okay, biggest thing. చూసుకోండి. సో ఎప్పుడు when you talk about your values అంటే ఏంటిరా? values అంటే you can simply say, sir, what is the value of I naught? కరెంట్ కదా, కరెంట్ కావాలిరా, ఒకసారి చెప్పండి. your current is equals to I naught into sin of omega t plus pi by 2. ఈ కేసులో your I naught is nothing but your v naught upon 1 upon omega into c. This quantity 1 upon omega into c is nothing but your reactance. ఈ reactance ని we will represent with a letter x. XL లేదా chi, right? It should be chi. Okay, technically it should be chi. చూసుకోండి. Okay, yes. లేదా you can simply say XL also, right? It depends on you. Okay, whatever you want to say you can call it. Your XL is equals to, చెప్పండి అందరికి, your XL is equals to 1 upon omega into c. ఇదే కదా? c అంటే capacitance, omega is your angular speed. అదే the same thing, students. Omega is related to your frequency. What is the relationship between frequency and omega, ra? Hey, your omega is nothing but 2 pi f. ఇదిగో సబ్స్టిట్యూట్ చేసుకోరా ఒక్కసారి. చెప్పండి your in what I'm writing, ra? Hey, this should be xc. Okay, here should be xc, ra. It is due to capacitance kada? Yes. So your capacitive reactance xc equals to 1 upon omega value is 2 pi f into c. ఇదిగో this is your capacitive reactance. Okay, capacitive reactance is this 1 upon 2 pi fc. F అంటే ఏంటిరా? F is frequency. Frequency చూసుకో. F అంటే ఏంటిరా? F అంటే ఇదిగో this is your frequency. What is frequency, sir? What is frequency రా? Frequency అంటే how many times your loop is rotating in a magnetic field in 1 second. 1 second. It will be given to you, okay? It will be given to you. Don't worry. Okay? Don't worry. It will be given to you, all of you. If you want, let us take a PYQ రా. కానీ అందరికి చూసుకోండి. Before proceeding further, I want to make one thing clear, one thing clear, okay? If at all you are being said, hey, చూసుకో. In an AC volt, it is the question. అందరికి చూసుకోండి. Your voltage is equals to 220 volt. ఇదిగో. And your current is equals to 2 ampere. Nothing mentioned kada. Nothing is mentioned about the type of voltage. Nothing is mentioned about the type of current. Mari aim voltage and aim current tiyali. What should you understand, right? It is your peak current, or it is your average current, or it is your RMS current. Ekkada kuda your voltage ante, is it your peak voltage? Hey, idigo kada. Your V is equals to V0 into sin of omega into D. Idigo. This V is what, ra? Your V0, your average V, average potential, or it is your RMS potential. Andariki cheppandi. When nothing has been mentioned, when nothing is mentioned, when nothing is mentioned, what you will be taking? Ante, what values are you going to consider? Your peak value, leda RMS value, leda average value. When nothing is mentioned, malli okkasari, is it V0, V average, or V RMS ra? When nothing is mentioned, and it has only been given that the voltage is 220 volt. What will you be assuming from this? Peak value, yes. So I'm only telling you slowly only, ra. చూసుకో. ఈ కేసెస్లో when nothing is mentioned, always remember, when nothing is mentioned, it must be your RMS conditions. You understanding? If a single voltage is given, yes, if a single voltage is given, your voltages and your currents, they must be in your RMS format. RMS ante entira? Ee RMS nunchi you can simply find out your peak values. Ade kada? Yes. You want to deal with the peak values, ra. Idigo here ee mottam cases lo what we are dealing is with your peak values, ra. Andariki your I0 ante entira? Peak value kada. It is V0 upon 1 upon omega c. Idigo these are the peak value conditions, ra. Kani you will simply not be given with these peak values in your questions. Mari em cheyali? You can find your peak values from the RMS values that are given. Idigo ade kada? Yes. So what is the relationship between RMS and peak, ra? Your IRMS is equals to I0 upon root 2. And at the same time, your VRMS is equals to same conditions, V0 upon root 2. Ide kada? Yes. So your VRMS, the potential RMS, is nothing but V0 upon root 2. Can you choose kondira? These are only valid when the current and potential are sinusoidal. Ade kada? Yes. So when I and V, they are sinusoidal, which is 99.9% case of your exams. Okay, for you, me kosam, 99% it will be sinusoidal. Okay, with that being said, ra, let us discuss about a PYQ. Okay, let us talk about one of the PYQs. Andariki. So, idigo. ampere, 0.93 ampere, 1.20 ampere, 0.35 ampere. చెప్పండి. హెచ్ఎం హాయ్. Time pass. Okay. Let us try to understand. Okay? చూద్దాం. All of you. So in case lo, you can simply say that nothing has mentioned about your voltage kada. Nothing. Ante what tracks? RMS. Correct. Ante your VRMS is equals to how much, sir? Your VRMS is 210. What is the value of your V0? VRMS ante V0 upon root 2 kada. That is equals to 210. Ante మీ V0 value is 210 into root 2. ఇదిగో ఒకసారి your V0 వచ్చిందంటే you can directly use the relationships. We have tremendous amount of relationships ra. What are the relationships? Your V0 is nothing but చెప్పండి లేదా your I0 is nothing but your V0 upon capacitive reactance. Capacitive reactance value ఏంటి సార్ అంటే V0 upon 1 upon omega into C ఇదే కదా. Omega value ఎంత రా? Omega value is 50 hertz kada. Yes, omega value is 50 hertz. Very good. And if you take it, you will be gone forever. Hertz, sir. Hertz ante it's a unit of frequency. 50 hertz ante na frequency ra. Ee question lo your F is 50 hertz and your VRMS is 210 volts. Chusko. This is the biggest mistake that the students do. Two mistakes. First mistake is they take it as V0. And the second mistake is that they consider it as omega. It's not omega. You understanding? Sorry. So now you can simply say, sir, V0 is divided by 1 upon E omega ki place. So I'll substitute 2 pi f kada. Yes. 2 pi f into C. You can replace it also, right? You can simply say, sir, V0 into 2 into pi into f into C is equals to I0. ఇప్పుడు మీ దగ్గర మొత్తం వాల్యూస్ ఉన్నాయి కదా. You have frequency, you have capacitance, you have V0 and you are also given that take pi value is nothing but 3.1. చూసుకో, సబ్స్టిట్యూట్ చేసి క్యాలిక్యులేట్ చేసుకోండి. Correct. From here you can simply say your I0 is nothing but 2 pi fc into V0. ఇదిగో. So 2 into pi value is 3.14, frequency 50, capacitance 10 microfarad అంటే -6 multiplied by V0 is 210 into root 2. ఇదే కదా. Yes. That's it. Calculate చేసుకో. You can easily do it. Okay? You can easily do it. I will not go into all these technical details. ఇప్పుడు let us talk something about your pure inductive. Hey, not pure inductive. I have to discuss some more things also. చూసుకోండి. Here. అందరికి. What I have to tell is, చూసుకో all of you. జాగ్రత్తగా వినండి. Okay? Your maximum current ఏంటిరా? పీక్ కరెంట్ కదా. పీక్ కరెంట్ వాల్యూ చెప్పు ఒకసారి. So sir, your current value in your capacitive circuit, మీ pure capacitive circuit లో your current is nothing but I0 into sine of omega t plus pi by 2 ఇదే కదా. I naught value ఏంటి సార్? I naught value is nothing but V naught divided by 1 upon omega into C, లేదంటే V naught into 2 pi f into C ఇదే కదా. వెరీ గుడ్, వెరీ గుడ్, వెరీ గుడ్. రైట్. that means hey జాగ్రత్తగా వినండి all of you, okay? that means if at all you are having a very high frequency అంటే ఏంటిరా? what can I say about the very high frequency? sir, your potential, ఇప్పుడు పొటెన్షియల్ గురించి చూద్దాం. ఓకే, అందరికి ఇప్పుడు పొటెన్షియల్ గురించి మాట్లాడుతున్నాం, చూసుకోండి అందరికి. సో కెన్ ఐ సింప్లీ సే ఫ్రమ్ దిస్ ఈక్వేషన్ I naught is equals to V naught into 2 pi f into C ఇదే కదా. సో యువర్ V naught వాల్యూ రా, చెప్పండి ఒక్కసారి. యువర్ V naught is nothing but I naught upon 2 pi f into C ఇదే కదా. దిస్ ఈజ్ యువర్ పొటెన్షియల్. పొటెన్షియల్ అంటే ఏంటిరా? పొటెన్షియల్ అక్రాస్ ద కెపాసిటర్ ఇదే కదా. V naught అంటే దిస్ ఈజ్ ద పొటెన్షియల్ అక్రాస్ ద కెపాసిటర్, ఆల్ ఆఫ్ యూ చూసుకో. దిస్ ఈజ్ ద పొటెన్షియల్. ఇప్పుడు వాట్ విల్ హ్యాపన్ ఇఫ్ యువర్ ఫ్రీక్వెన్సీ ఈజ్ వెరీ హై? ఫ్రీక్వెన్సీ వెరీ హై అంటే ఏంటిరా? ఇఫ్ యువర్ ఫ్రీక్వెన్సీ ఈజ్ వెరీ హై, వాట్ కెన్ యూ ఇన్ఫర్ ఫ్రమ్ దిస్? ఓకే, let us talk about the field format. చూసుకో. if this is your capacitor, అందరికి, if this is your capacitor and to this capacitor I am attaching an AC source ఇదే కదా. yes. so what's happening ra? in a single second the charge లేదా this capacitor is charging and discharging thousands of times ఇదే కదా. yes, thousands of times. అంటే if you increase the frequency more, if you are increasing the frequency more, ante the capacitor is not getting the time to charge at all ide kada. yes, ante if the frequency is very high, very high, ante your capacitance is just not getting the time to charge. Enduku sir? Because some current passed to charge the capacitor, kani at the same time the current came, again it is going, again coming, again going, again coming, until this capacitor gets confused. It will not charge at all. ఎందుకంటే ఒక్క సెకండ్ లో thousands of times the charge is going and coming, going and coming, going. What will you understand? Nothing కదా. yes. hey, try to understand. I don't want to go much deep into it, kani I just want to give you the feel of these things. okay, feel తీసుకోండి if you are interested. లేదంటే we can directly proceed. okay, we can directly proceed to your inductive circuits. చూసుకోండి, మీ inductive circuits లో you are talking about pure inductive circuits ఇదే కదా. yes, pure inductive circuit. ఇప్పుడు చూసుకోండి అందరికి, if it is a pure inductive circuit అంటే ఈ సర్క్యూట్ లో you have an inductor and you have a AC source. I'm sorry. ఇదే నీ AC voltage కదా. yes, your AC source, whatever it is. ఫార్ములా చెప్పండి ఒకసారి. V is equals to V naught into sin of omega into T ఇదే కదా. yes, ఇండక్టర్ అంటే ఇండక్టెన్స్ వాల్యూ ఉండాలి. that inductance value is L ఇదే కదా. yes. so the potential difference across this battery should be equals to the potential difference across this inductor రా. కానీ మా అందరికి తెలుసు కదా, what is the potential difference across inductor sir? L into di upon dt. ఇదిగో this is the potential difference, must be equals to potential difference across it అంటే V naught into sin of omega into d. ఇదిగో from here you can simply say sir di upon dt is equals to ఈ L ని అక్కడ పంపేయండి రా. you can simply say V naught upon L కదా. yes, sin of omega into t. ఇప్పుడు ఈ dt ని కూడా you send it that side, you are left with di is equals to V naught upon L times of sin of omega t dt. integrate చేసుకోండి. సో వెన్ యూ ఆర్ ఇంటిగ్రేటింగ్ రా, చెప్పు, మొత్తం కాన్స్టెంట్ టర్మ్స్ ని బయటికి తీసుకోండి ఇదే కదా. yes, so what you will do is, hey, let me write, shifted everything on a fresh side. hey, you also ra, go that side. oh good. ఇప్పుడు చెప్పండి ఒకసారి, your integral di is nothing but I కదా. yes, I. What are the constant terms రా? రైట్ సైడ్ లో మొత్తం కాన్స్టెంట్ టర్మ్స్ ని బయటికి తీసుకోండి. దట్ ఈస్ ఈక్వల్స్ టు సార్ v నాట్ అపాన్ ఎల్. ఎప్పుడు వాట్ ఈస్ రిమైనింగ్ అంటే యువర్ సైన్ ఆఫ్ ఒమేగా టీ డిటి. ఇదిగో ఇప్పుడు వాట్ ఈస్ ద ఇంటెగ్రల్ ఆఫ్ సైన్ ఆఫ్ ఒమేగా టీ? ఐ నో ఓకే, నాకు తెలిసి రాస్తున్నావు చూసుకోండి అందరికి. సో యూ కెన్ సింప్లీ సే యువర్ ఐ ఈజ్ నథింగ్ బట్ v నాట్ అపాన్ ఎల్. చూసుకోండి ఈ ఒమేగా దిస్ విల్ కమ్ ఇన్ డినామినేటర్ అండ్ ఇంటెగ్రల్ ఆఫ్ సైన్ ఈజ్ నథింగ్ బట్ minus of cos of omega into t. So you can compare it. Your I is nothing but v naught upon omega into L multiplied by, choose kondira, what is the voltage? Voltage is in sine. Can your current is in cos. Adi kuda negative cos. So I have to convert it. Convert cheyali kada? Yes. So ela convert cheyali ra? You do the same thing. Ante you can simply say, understand, okay, your I is equals to, I'll write for you here. So negative cos theta is sine of theta minus pi by 2. Understand? Sine of theta minus pi by 2 is minus cos theta. Other. So you can simply say it is nothing but sine of theta value entira, sine of omega t minus pi by 2. Adigo. This is the value of your current. You can simply say I naught, I is nothing but v naught upon omega L sine of omega t minus pi by 2. Hey, last low I will also be comparing a few things. Hey, జాగ్రత్తగా వినండి. అదే, సో ఫ్రమ్ హియర్ ఈ మొత్తం క్వాంటిటీ రా చూసుకోండి, ఇదే ఈ మొత్తం ని విల్ కాల్ ఇట్ యాజ్ ఐ నాట్ కదా. ఎస్, సో హియర్ యూ కెన్ సింప్లీ సే సార్ ద వాల్యూ ఆఫ్ ద కరెంట్ ఐ ఈజ్ నథింగ్ బట్ ఐ నాట్ ఇంటూ సైన్ ఆఫ్ ఒమేగా టీ మైనస్ pi by 2. అదే, దిస్ ఈస్ ద వాల్యూ ఆఫ్ ద కరెంట్. అంతే కదా. ఎస్, ఇప్పుడు ఐ నాట్ గురించి చెప్పండి అందరికి. ఐ నాట్ ఈస్ నథింగ్ బట్ వి నాట్ అపాన్ ఒమేగా ఎల్. అరే రిమెంబరింగ్ సంథింగ్ రా, వి నాట్ అపాన్ సంథింగ్, వి నాట్ అపాన్ సంథింగ్. ఆ సంథింగ్ ని వి హావ్ సెడ్ సంథింగ్. సో సార్ వి నాట్ అపాన్ సంథింగ్ ఈజ్ నథింగ్ బట్ వి నాట్ అపాన్ రెసిస్టెన్స్. చూసుకోరా, when you had a pure resistive circuit you simply say sir I naught is nothing but v naught upon r. When you have a capacitive circuit ante me pure capacitive circuit lo what did we say sir I naught is nothing but v naught upon 1 upon omega c ide kada. Yes, and in your pure inductive circuit what is the value? I naught is v naught upon omega l. Hey, I naught is nothing but v naught upon omega l kada. Yes, చూసుకోండి రా, denominators. When it was resistive circuit we said ఇదే అంటే నా resistance ఇదే కదా. Yes, కానీ you can't always talk about resistance కాబట్టి we give a different name. అంటే name is different but the meaning is same. Resistance అంటే obstacle కదా. Yes, ఇక్కడ కూడా this capacitance will give some obstacle. ఈ obstacle ని we will be calling it as reactance కానీ due to capacitor, therefore we will say capacitive reactance. Here అరే మళ్ళీ ఒక్కసారి the same thing రా, divided by something కదా, divided by something ఉంటే do the same thing. What is it sir? It is also the reactance కానీ it is due to inductor కదా, కాబట్టి నేమ్ is inductive reactance. పేరు గుర్తుపెట్టుకోండి. The names are important and at the same time the values are also important. అదే కదా. Hey, చూసుకోరా. So when you have a resistor only R, reactance X అంటే reactance, capacitive reactance ఉంటే 1 upon omega C. Hey, X అంటే reactance, inductive reactance ఉంటే omega into L. ఇదిగో, these are very important formulas and very important properties. అంతే కదా. Yes. Now we are talking about the current equations ra. ఇప్పుడు let us go back to each and every case and let us see the values of current. Okay, circuit elements అంటే resistor, capacitor, inductor అదే కదా. Yes, so when you have your resistor ra, మీ ప్యూర్ రెసిస్టివ్ సర్క్యూట్ లో కరెంట్ వాల్యూ ఒకసారి చెప్పండి. I naught sin omega t కదా. Yes, ఇది వాల్యూస్ గుర్తుపెట్టుకోండి. your pure resistance అంటే I naught sin omega t. What about the next ra? When you had a pure capacitive circuit, what is the value of current ra? Hey, where is it? Did I write? Yes, here చూసుకోండి. So when you have a capacitive capacitive circuit ఈ కేసులో I is equals to I naught sin of omega t plus pi by 2 plus pi by 2. Resistance లో I equals to I naught sin omega t అంతే. Capacitor లో I naught sin omega t plus pi by 2. Inductor లో ఈ plus pi by 2 కి ప్లేస్ లో you write minus pi by 2 అదే ఇదిగో. So when you have your inductance, when you have inductive circuit, I naught sin omega t minus pi by 2 అదే కదా. ఇప్పుడు కంపేర్ చేసుకోండి ఒకసారి. సో కరెంట్ వాల్యూస్ గురించి మాట్లాడుతున్నాం చూసుకో. కరెంట్ అండ్ వోల్టేజ్ వాల్యూస్, ఓకే, కరెంట్ అండ్ వోల్టేజ్ values for your inductive లేదా for different circuits, అదే different circuits. It's a very simple topic ra, okay, it will slowly get complicated andariki. So if you are not thorough with this ra, meeku chaala problem vastundi. Okay, yes, hi Shalini, hi after a long time. Anyway, చూసుకోండి రా. So voltage value does not change. V equals to, hey, let us make cases first, okay? So if you have a pure resistive circuit, when you have pure capacitive circuit, and lastly, when you have pure inductive circuit. ఈ మొత్తం కేసెస్ లో నాకు వాల్యూ ఆఫ్ పొటెన్షియల్ అండ్ కరెంట్ కావాలి, అదే కదా. ఎస్, యూ రిమెంబర్ దిస్, క్లోజ్ యువర్ ఐస్ రా, క్లోజ్ యువర్ ఐస్. The potential value does not change. Ante your potential remains the same in all three of them. In all three of them. Choose. Ante when you are talking about the potential value here, your potential is gonna be V naught sine of omega into t. Ikkada kuda the same value, V equals to V naught sine of omega into t. Here also same value, V naught sine of omega into t. Enduku sir? Because this voltage is nothing to do with this resistor, capacitor, inductor. It has been created by rotating a coil in a magnetic field. Ade kada? Yes. So the number of rotations, the number of turns of the coil decides this potential. Not the capacitor, inductor or resistor. Okasari your potential has been created, then we are adding these three with your potential and we are making different cases. Ade kada? Yes, very good. Ippudu chudandi andariki. When your potential is same ra, idi chala important factors, okay, andariki jagrataga gurtu pettukondi. Hey, listen to me very careful ra. Dan tarvata, if you don't understand, then you will give me a headache, sir. How did come? How did that come? Ye kaisa, wo kaisa? I don't want all that risk, okay? Okay, kabatti hear from here itself. So when you had, hey, what happened? Hey, yes. So when you had your pure resistive circuit, pure resistive circuit lo, your current value cheppandi okasari. We have derived all the results. Sir, I naught into sine of omega t. Idigo. Good, very good, no problem. So far so good. Ippudu come here and tell me ra, I is equals to I naught into sine of omega t plus pi by 2. Capacitive kada? Yes. What about inductive ra? Inductive case lo, you can simply say, sir, I is equals to I naught sine of omega t minus pi by 2. And for sure, I naught values are different for different cases. Choose. So when you have a resistor, your I naught value is nothing but V naught upon R. V naught ante enti ra? This V naught. This V naught, okay. Here also your I naught value is nothing but V naught upon V naught, okay. It should be V naught upon 1 upon omega c. And when it comes to your inductance, your I naught value is nothing but V naught upon omega into L. L ante inductance. అర్థమైంది అందరికీ? రైట్. ఇప్పుడు let us talk about the relation of current and potential ra. If you are well equipped with your SHM, simple harmonic motion, you will come to know ra, phase చూసుకో. phase ante omega t same phase. Ante your current and potential are in same phase. Ade kada? Yes. So they are in the same phase. Good. కానీ మీ సెకండ్ కేసులో your potential is omega t and your current is omega t plus pi by 2. అంటే current is ahead ahead. ఎందుకంటే it's more కదా. Yes. That means your current is ahead. Resembles my spelling కదా. Yes, ahead of potential. లేదా స్టాండర్డ్ టర్మినాలజీ తీసుకోండి. స్టాండర్డ్ టర్మినాలజీస్లో we simply say current. I అంటే current కదా. Yes, current leads ఎందుకు leads సార్? Because it's more కాబట్టి it leads potential by యాంగిల్ చెప్పురా, by pi by 2. అదే కదా. ఎస్. అండ్ యువర్ ఇండక్టివ్ కేసులో చెప్పండి, యువర్ కరెంట్ ఇఫ్ ఇట్ ఇస్ లీడ్స్ ఇట్ లాగ్స్ రా, బికాస్ ఇట్స్ లో. చూసుకో తక్కువ కదా. ఎస్, ఇట్ లాగ్స్ యువర్ కరెంట్ lags your potential difference by an angle of pi by 2. Oh, good. అదే. ఇప్పుడు what will happen if we take two combinations together? అంటే your resistance plus capacitance, your resistance plus inductance, your capacitance plus inductance, and last load all of your resistance, capacitance, inductance. Okay, we will be seeing that. దాని తర్వాత we will be talking about your transformers and this chapter will be completed. The break is coming at 9 p.m. అందరికి. Okay, we will take a break at 9 p.m. ఇప్పుడు let us take some questions based on it అందరికి, if possible from PYQs రా. Next 2024 లో you have two questions from the same chapter. Okay, క్వశ్చన్ తీసుకోండి. An inductor of 2 Henry, okay, inductor and units should be Henry, is connected across an AC source that generates లేదా that varies, okay, that varies with time. Varies అంటే potential varies, okay, potential varies with time as V is equals to 10 sine of 2.5t. Find the equation of current. This one. Inductor of 2 Henry, okay. Hey, it's not visible in the frame kada, so let me just bring it slightly down. Good. Very good. Student. So your format for your current is like this, ra. Ide kada. I should be I naught sin of. Ippudu, because it's the inductive circuit. Inductive circuit unte in current there will be a negative term. Chuskondi. I naught sin of omega t minus pi by 2. Capacitive unte sin of omega t plus pi by 2. This is a very important result. All of you remember it. Okay, right, correct. So from here you can simply say sin of omega t minus pi by 2. ఇప్పుడు వాల్యూ సబ్స్టిట్యూట్ చేసుకోండి. అదే యువర్ I naught is nothing but V naught upon omega into L. అదే కదా. ఎస్, సైన్ ఆఫ్ ఒమేగా వాల్యూ వింటారా? ఒమేగా అంటే 2.5t, అదేగా 2.5t minus pi by 2. V naught value is 10, omega is 2.5 and your inductance is 2 kada. Yes, so your I should be equals to like this, ra, multiplied by sine of 2.5t minus pi by 2. Ante your I is nothing but 10 by 2.5, 5 ra, 5, 10 by 5 అంటే 2. ఇదే కదా. Yes. Let us take one more questions, ra. Okay. The same question, okay. Pure capacitive circuit. Has a capacitance of 10 microfarad. ఇదే కదా. Yes. Correct, not correct, ra. I think it's correct only. Okay, it's correct only. Whatever it's coming, do it. కొంచెం యూస్ఫుల్ డిస్కషన్స్ కావాలిరా. ఓకే, టాకింగ్ సంథింగ్ నాన్ సెన్స్ ఇన్ ద చాట్ బాక్స్. అదే there are hardly 5 to 6% of active listeners. Active listeners ante the serious aspirants. What all I can sense is that ఇప్పుడు I don't know. You're asking about your schools, you're asking about your colleges. Negative, huh? Is it negative? Negative coming, ra. Should not be negative. సరే చూద్దాం. సో your if at all your V value is V naught into sin of omega t ra, ఇదే voltage value ఇదే ఉంటే you can say that your current will be more అంటే your I should be I naught into sin of omega t plus pi by 2. కానీ what if your current itself is omega t రా? ఈ కేసులో try to understand the reverse. Reverse ante entira, మీ కెపాసిటివ్ సర్క్యూట్లో కరెంట్ లీడ్స్ పొటెన్షియల్ బై పై బై 2 అదే కదా. రివర్స్ చేసుకో ఒక్కసారి. దాట్ మీన్స్ పొటెన్షియల్ లాగ్స్ అంటే ఇఫ్ యువర్ కరెంట్ వాల్యూ ఇస్ I0 into sine of omega t, your potential value must be equals to V0 sine of omega t minus pi by 2 రా చూసుకో. Then and only then it will be more, current will be more. That means potential should be less than pi by 2. Point number 1. Okay, ఈ వాల్యూ వచ్చిందిరా అంటే వాట్ ఎవర్ ద పొటెన్షియల్ విల్ బి, నాకు V0 వాల్యూ కావాలి ఫర్ షూర్. I don't know anything about it. కానీ I have known about sine of చెప్పు omega t అంటే 3t minus pi by 2. This is a value. ఇప్పుడు V0 వాల్యూ కావాలి ఇదే కదా. What do you know about I0 రా? I0 is nothing but V0 upon 1 upon omega into c ఇదే కదా. Yes. So from here send it that side. Your V0 should be equals to I0 divided by omega into c. V0 is I0 value in the sir. I0 is it given? Yes, 2. చూసుకోండి. I0 is 2 divided by omega value in the sir 3 into c value రా. What is the value of c? 10 microfarad ante 10 into 10 to the power minus 6. There you go. So your V0 value comes out to be minus 5 kada, goes up plus 5. So it is 2 by 3 into 10 to the power 5. Substitute. So 2 by 3 into 10 to the power 5 into sine of 3t minus 5. 1, 2, 3, 4 only ra. 4 only. 4 or 5. 4 zeros, 5 zeros ra. It's 10 microfarad kada. Minus 6. Minus 5. It becomes plus 5. So it should be 2 lakhs, not 20,000. Okay? Should be 2 lakhs. Yes, correct. Correct only. Your formula is minus 1, 2, 3, 4, 5 divided by 3 into cos of 3t. There you go. This is the same answer. This and this mean the same. Okay. No, V0 is not I0 into omega c. V0 is I0 by omega c. Choose. This entire thing it's in division kada. You are sending it as a whole. Try to understand. Okay, this is in division ra. So when you are sending it in multiplication, it goes like this into. So I0 into 1 upon omega c becomes I0 by omega c. Okay. Yes. Sorry. Next. ఇప్పుడు let us talk about the combinations రా. Combinations అంటే ఏంటి రా? Should I take it? What's the time? 42. Do you think it's possible? Sorry. Hey, let us talk about some more things about the inductive and capacitive reactance only. Okay, choose. So let us talk about your normal resistance R. Let us talk about your reactance ra. Capacitive reactance ante 1 upon omega into c. Ide kada. Let us talk about your inductive reactance. Inductive reactance ante your L. It is omega into c. Ide kada. Can we do something ra? Can we do something? Sirs. What reverse? Reverse ante? What do you mean by reverse ra? What do you mean by reverse? See, there should the formula is like this, okay? I0 is nothing but V0 upon 1 upon omega c. C for capacitance. This is the formula. Multiplied by sine of omega t plus pi by 2. Hey, it is valid when your voltage is changing like this. V0 into sine of omega into t. This is a formula. So ఈ మొత్తం term, this is in division కదా, you send it there in multiplication. You're understanding? That means you'll simply get, లేదా I don't need this also ra, okay? Sign, I'm not interested. I want the maximum value కదా. Peak values గురించి మాట్లాడాలంటే this are the relationship between peak values. ఇప్పుడు take it that side. అదే you'll get the simply same thing. What can you say simply, sir? I naught into 1 upon omega into c is equals to v naught. అంటే your I naught divided by omega into c is v naught in your capacitive circuit. Okay, this is all about your capacitive circuit. It's not reverse, it's the same. Okay, it's the same. Okay, this is for your capacitive circuit. For your inductive circuit గురించి చెప్పండి. For your inductive circuit, what is the scene ra? Inductive గురించి చెప్పండి ఒకసారి. మీ inductive circuit కోసం you can simply say, sir, your I naught is nothing but what is the value ra? V naught upon omega into L. ఇప్పుడు when you talk about the V naught and I naught relation, send it that side. అదే you can simply say your V naught is nothing but I naught into omega into L. This is your maximum voltage. And let us compare also now. Your first case low, your current I is equals to I naught into sine of omega t. If current is directly given, you can jump to your potential. Potential and enti ra, your potential చూసుకోండి. This is given, this should be found ra. Your V should be equals to V naught into sine of omega t plus pi by 2. ఎందుకు sir? Because in your inductive circuit, the potential leads and the current lags. Understanding? So if this condition is given, if your current is this, potential will be that. V naught value ఏంటంటే this is your V naught value. అంటే your V should be equals to I naught into omega L into sine of omega t plus pi by 2. But or లేదా if your potential is given and V is equals to V naught into sine of omega t. If it is given like this ra, ఈ case లో your current changes. మీ current value అంటే it should be I naught into sine of omega t minus pi by 2. చూసుకో. You understanding? Yes. అంటే ఈ రెండు cases లో కూడా your current is less and your potential is more. అదే కదా? Yes. ఈ case లో your I naught is nothing but your V naught upon inductive reactance అంటే XL value అంటే omega L. అదే. That means you will simply say I is equals to V naught upon omega into L multiplied by sine of omega t minus pi by 2. ఇదిగో. This is a comparative relationship. Okay? If one is given, other should be found. If one is given, other should be found. అంతే కదా? Yes. So ఇప్పుడు let us talk something about the graphical representation. Graphical representation అంటే ఏంటి? When it's simply a resistive circuit, your resistance is R. అంటే this resistance is not changing with time. లేదా not changing with frequency. అదే కదా? Yes. కానీ when you talk about your reactances, your XC, మీ XC and your XL, it should be XL, okay? It should be XL. XC and XL గురించి మాట్లాడితే these are the formulas. ఇప్పుడు చూడండి అందరికి. Can I simply say that ఈ కేసులో your XC అంటే reactance is inversely proportional to capacitance. అదే కదా? కానీ ఈ కేసులో your reactance is directly proportional to inductance. అంటే when I am drawing a graph, చూసుకోరా ఇదే నా inductance, this not inductance రా, this is my reactance and this is my inductance. అదే కదా? Yes. గ్రాఫ్ గురించి చెప్పండి ఒకసారి. It is directly proportional అంటే this. You are understanding? Yes. కానీ when you come to the capacitor part రా, చెప్పండి. So this is your capacitive reactance and ఇదే మీ capacitance ఉంటే something like this. But the most standard and beloved part is your resistance. చూసుకోండి. This is your resistance. This is your resistance. Hey, what should I take? What should I take? Resistance only kada? Yes, so it is not changing. Your resistance is constant. చూసుకోండి. అంటే whatever you take, లేదా you call it as resistive reactance XR or XC, C, XL, L. ఇప్పుడు I think it's more clear. Okay? Try to understand the graphs. You are understanding Yes. If you want to simplify some things, right, you can simplify also. Cheppandi. You can simply say that xc is equals to 1 upon omega into c. Ide kada? Yes. That means you can simply say, sir, omega is nothing but 1 upon xc into c. Correct? Correct. చూసుకోండి. ఎక్కడి నుంచి what can you say about xl ra? Your xl is omega into l kada? Yes, your xl is your omega into l. అంటే ఎక్కడి నుంచి your omega is nothing but your xl upon l. ఎదిగో, this is your omega, this is your omega. If you want, you can compare it also. అంటే when you are saying or లేదా when you are clubbing them together, what you can say is your 1 upon xc into c should be equals to xl upon l. And you can take the relationships also. This is a relationship. అర్థమైంది అందరికీ? Yes. Do the cross multiplication. L is equals to xl into xc into c అంటే your xl into xc is equals to l upon c. Okay, ante kada? Yes. So this are the values for your separate circuit elements. Okay, separate circuit elements. ఈ మొత్తాన్ని, okay, whatever it's there, చూసుకోండి. You call them ohmic resistances. Video 0.25 లో పోయింది సార్. Yes, ohmic resistances అంటే your R, మీ XC and your XL. You're understanding? R అంటే resistance, XC అంటే your capacitive reactance, XL అంటే మీ inductive reactance. చూసుకో, మళ్ళీ ఒకసారి రాస్తున్నాను. your XC is nothing but the obstacle లేదా the resistance. Okay, resistance offered by capacitor. Okay, resistance offered by capacitor to the AC source. అదే కదా? Right. What about your XL ra? XL is nothing but resistance offered by inductor లేదా yes inductor to AC source. ఇప్పుడు చూడండి రా, if the resistance is maximum, resistance maximum ఉంటే what can you say about it రా? If your resistance is maximum, hey, you can simply say, sir, if your XC అంటే your resistance is maximum అంటే ఏంటి రా? that means what? That means what రా? energies. Yes, energies also will be maximum. అంతే కదా? Yes, try to understand all of this రా. Okay, so ఇప్పుడు we have to talk about your combinations అంటే your LC circuit, RC circuit, LCR, then transformers, and then power, and then your entire chapter will be completed. అంతే కదా? Yes, so let us take a break now. అందరికి. Okay, but before that, I was telling something wrong. Forgetting something. చూసుకోండిరా. Now we have two different cases, okay? Two different cases అంటే you have higher frequencies, you have lower frequencies. ఈ మొత్తం గురించి we will have to classify them in these two different columns. అంటే ఏంటిరా, మీ ఫస్ట్ కేసులో your frequency is high. Frequency is high. Frequency high ఉంటే చూసుకోండి your XL, not XL, sorry, I'm sorry. Your XC అంటే capacitive reactance inversely proportional to frequency కదా. So if your frequency is increasing, your XC should decrease. XC అంటే ఏంటిరా, your XC అంటే your capacitive resistance. So if your resistance is less, decrease it. It becomes zero. Zero అంటే ఏంటిరా, wire కదా. Yes. అంటే if your XC is very low, very low అంటే ఏంటిరా, that means your resistance is very low. That means your capacitor behaves as wire. అంటే ఏంటిరా, if your frequency is high frequency ఉంటే your capacitive circuit చూసుకోండిరా, this is your capacitor కదా. Yes, it can be considered as short circuiting ray. Hey, short circuiting లో your capacitance has been replaced with wire. అంటే short circuiting. What if the reverse ఇప్పుడు you can assume by yourself also ra. Reverse case లో your frequency is low, okay? Frequency is low. మళ్ళీ ఒకసారి if your frequency is low అంటే your XC is very high. If your very high resistance is there, what does it mean? Ante your capacitor gets replaced with an open circuit. Chuskondi ide nee open circuit ante there will be no current flow. You are understanding? Yes, here also the same. Kani ee case it will be reverse ante entira for low frequencies ante entira slowly the current is changing ede kada. Yes, for low frequencies your XL is directly proportional to L frequency F. Ante your XL is low ante resistance is low kada. Yes, for very low frequencies, your XL tending to 0 ante it behaves as a straight wire. Ante for low frequencies your inductor across an AC source can be replaced with a wire across your AC source ra. Chusko. Okay, right. And opposite also vice versa ra chuskondi. For high frequency అంటే ఏంటిరా, మీ దగ్గర హై ఫ్రీక్వెన్సీ ఉంటే చెప్పు, ఫ్రీక్వెన్సీ హై అంటే XL కూడా హై కదా. ఎస్, యువర్ XL is high అంటే రెసిస్టెన్స్ ఇస్ హై రా. సో ఈ కేసులో యువర్ ఇండక్టర్ బిహేవ్స్ యాజ్ an open circuit for this AC source. గుర్తుపెట్టుకోండి, these are the important results. Yes, if XC and XL becomes equal, then it comes out to be your omega should be equals to 1 upon root of LC. Then you simply say they cancel one another and your your circuit becomes pure resistive circuit. We will see about it later, okay? After break we will be seeing all these things, okay? It is possible for them to become equal, ra. So if your XC equals to XL, your omega value becomes this. Until your frequency becomes 1 upon 2 pi root of L into C. That means if I am rotating the disc, లేదా loop at this frequency, the inductance and capacitance, although they are there, their effects will be cancelled out. Okay? Ante. We will be discussing it, all of it. Chusko. Kani, first we will take a break. Okay? Break till దాని తర్వాత we will discuss these things, all of you. Then we will talk about combination. Combination అంటే ఏంటి సార్? ఈ combination లో your RC, your RL circuits. Okay? Then we will talk about a combination అంటే LCR circuit. Okay? After that, it's visible. Yes, it should be visible to you. this. Hey, not this. ఈ LCR తర్వాత what's remaining రా? Remaining about power in alternating currents. Then we have something known as transformers. Okay, after transformers, your chapter is complete. Okay, yes. ఎప్పుడు time for a break. Okay, సరే. Let's meet at 9:10 p.m. అందరికి. Timing. I have. Hey. Yes, the dinner is there. Dinner is there, so it will take some little longer. Okay, so let us take it till 9:40. Andariki. 9:40. Hi, 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 hi. Hello, everybody. Hi, hi. Hello, everybody. Elanaru. So back after the break, and we will be talking now about all these things. Okay. Sorry. So ఇప్పుడు let us talk about the combinations. Combinations అంటే ఏంటి, sir? Let us combine your resistance with capacitor, and let us also combine your resistor with your inductor. Okay, and let us see what happens now. Yes, done. సరే. సో ఇప్పుడు let us see everything one by one. అందరికి చూసుకోండి. కానీ కానీ ఆ మొత్తం డిస్కస్ చేసి ముందు ఐ వాంట్ టు అండర్స్టాండ్ సంథింగ్ అబౌట్ డిఫరెంట్ థింగ్స్ రా. అంటే కాంబినేషన్ ఆఫ్ టూ ఎస్హెచ్ఎమ్స్ గుర్తుందా? వి టాక్డ్ అబౌట్ యువర్ వేవ్స్. మీ వేవ్స్ లో వి టాక్డ్ అబౌట్ యువర్ కన్స్ట్రక్టివ్ అండ్ డిస్ట్రక్టివ్ ఇంటర్ఫిరెన్స్, అదే కదా? ఎస్ ఎస్, వి టాక్డ్ అబౌట్ యువర్ కన్స్ట్రక్టివ్ అండ్ డిస్ట్రక్టివ్ ఇంటర్ఫిరెన్స్. అంటే ఇఫ్ యూ హ్యావ్ టూ డిఫరెంట్ ఎస్హెచ్ఎమ్స్ రా, చూసుకో. The first equation is y1 is equals to a1 times of sine of omega into t. y2 గురించి మాట్లాడాలంటే let us say a2 times of sine of omega into t plus 5. ఇదిగో. So 5 అంటే some extra phase difference. In the initial phase, okay, in the initial instance, whatever your extra phase difference is there, we are naming it as 5. అందరి. So ఇప్పుడు when you add these two, just results గుర్తుపెట్టుకోండి. Okay, you don't need anything else రా. So just remember the results. So what is the result అంటే you can simply say your y net is equals to your a net into sine of, చెప్పండి, omega t is there రా, కానీ at the same time you have some other angle alpha. Alpha is not phi. Phi is not alpha. Alpha is alpha, phi is phi. అదే కదా? Yes. సో ఈ ఆల్ఫా గురించి చూద్దామంటే యూ కెన్ సింప్లీ సే, సార్, ఆల్ఫా ఈస్ tan ఇన్వర్స్ ఆఫ్ a2 టైమ్స్ ఆఫ్ సైన్ ఆఫ్ ఫై డివైడెడ్ బై a1 ప్లస్ a2 టైమ్స్ ఆఫ్ కాస్ ఫై. ఇదే కదా? ఇఫ్ యూ నో ఆల్ దీస్ థింగ్స్ రా, యూ డోంట్ హ్యావ్ టు వరీ అబౌట్ ద ఫర్దర్ డిస్కషన్ దట్ ఈస్ కమింగ్ ఇన్ అవర్ డిస్కషన్స్. అర్థమైంది? రైట్. ఎస్ ఎస్ ఎస్, డన్. ఇప్పుడు let us talk about two different SHMs. అదే కదా? I'm telling you once again, చూడండి అందరికి, two different SHMs are there. Okay, a1 sin of omega t. మీ సెకండ్ కేసులో you have a2 sin of omega t plus 5. అదే కదా? Yes. సరే. So now let us talk about three different components in three different frames రా. అదిగో. ఫస్ట్ అంటే మీ రెసిస్టర్. ఓకే, రెసిస్టర్. What does the resistor do రా? It tries to keep the current in the same phase as the potential. Ante kada? Yes, that is the property of your resistor. What is the property, sir? It will always try to, resistor keeps, చెప్పండి, keeps the current in phase. Okay, keeps the current in phase with your voltage. అంతే కదా? This is the function లేదా the work of your resistor. Resistor తర్వాత we already seen about your capacitor. ఇదే కదా? Yes. What does the capacitor do? The capacitor increases. అదే కదా? Yes. Increases phase difference. లేదా basically you can simply say increases the current అందరికి phase difference. And what about inductor? Exactly opposite of resistor. Capacitor, sorry, exact opposite of capacitor. ఇదే కదా? Yes. So if this is your inductor, what it does is it decreases current. ఇదిగో. Resistor keeps current same. Inductor decreases the current. Capacitor increases the current. అదే కదా? Hey, వినండి all of you. Now, let us try taking the combinations of both of them. అంటే మీ ఫస్ట్ సర్క్యూట్ విల్ బి యువర్ ఆర్సీ సర్క్యూట్. ఆర్ అంటే రెసిస్టర్, సి అంటే కెపాసిటర్. ఇదే కదా? ఎస్. సో ద ఫస్ట్ కాంబినేషన్ దట్ వీఆర్ గోయింగ్ టు డూ ఇస్ విత్ యువర్ రెసిస్టర్ అండ్ యువర్ కెపాసిటర్. చూద్దాం హౌ ఇట్ బిహేవ్స్ అండ్ హౌ ఆర్ ద ప్రాపర్టీస్. హాయ్ హాయ్ హాయ్, హలో హలో హలో. సో when we are talking about your capacitance and your resistance, చూసుకోండి అందరికి. అంటే ఒకటే సర్క్యూట్లో you have your resistance and you have your capacitance. కానీ both of them they have attached to an AC voltage. అంటే V equals to V0 times of sin of omega into T. ఇప్పుడు చూడండి అందరికి, your resistance tries to keep current in same phase. ఇదే కదా? Yes. What about your capacitance? This tries to increase the current. ఇదే కదా? Yes. This tries to increase the current. All of you try to understand. అంటే one is at 0 అంటే phase difference is 0 and one is at the phase difference of pi by 2 higher. ఇదే కదా? Yes. So the resultant will be between these two. As you remember, we talked about resultant of vectors. It is between the vectors kada? Yes. And your net phase లేదా your net phase difference will be between 0 and pi by 2. Point number 1 to be noted. And let us talk about your resistor. Current due to resistor. చెప్పండి, your current due to resistor is I0 into sin of omega into t. ఇదే కదా? Yes. ఇప్పుడు current due to your capacitor చెప్పండి అందరికి, your current due to capacitor is I0 into sin of omega t plus pi by 2. If you want to analyze, you can say simply the angle between 0 and pi by 2 also. లేదంటే you want to go mathematically చూసుకోండి. These are the two SHMs కదా? Yes. అంటే I0 వాల్యూ చెప్పండి ఒకసారి. That you will say simply sir I is equals to V0 upon R. ఇదే కదా? Yes. I0 అంటే V0 upon R. ఇక్కడ చెప్పండి your I0 వాల్యూ sir I0 is equals to చెప్పండి V0 upon 1 upon omega into C. ఇదే కదా? ఇప్పుడు when you talk about the resistances గుర్తుందా? Resistances గురించి చూద్దామంటే you can simply say sir for your resistance చూసుకోండి R, resistance is equals to R. Understanding? For your resistance is equals to R. కానీ your capacitance, the resistance is equals to చెప్పండి resistance లేదా reactance కదా? That is equals to 1 upon omega into C. ఇదిగో. You are understanding? అంటే నాకు net resistance కావాలంటే the formula for this net resistance comes out as చెప్పండి R net is equals to root of R1 squared plus R2 squared. అదే. How did it come, sir? How did it come? Simple SHM రా. SHM ని యాడ్ చేసుకోండి. అదే. Then you will automatically come to know this. చూసుకోండి. To understand this whole process, your SHM should be good. అంతే కదా? Here. Try to understand all of you. ఈ కేసులో this your an కదా? What is the formula for an? An is nothing but root of a1 squared plus a2 squared plus 2a1 a2 cos phi. ఒకసారి SHM చూసుకోండి. It is very important formula రా. Phi అంటే ఏంటి రా? Phase difference, initial phase difference చూసుకో. omega t plus phi కదా? So ఈ phi కి వాల్యూ pi by 2 చేస్తే this term will be gone kada? So you can simply say sir a net is equals to root of a1 squared plus a2 squared. ఇదే కదా? Similarly, here also you will be saying sir R net is equals to root of R1 square plus R2 square. ఎందుకు sir? Because the initial phase difference is pi by 2. చూసుకో. Here it is pi by 2, here it is 0. You are understanding? Yes, so at the same time this net resistance is known as the impedance. Okay, గుర్తుపెట్టుకోండి, impedance అంటే letter Z రా. Impedance అంటే ఏంటి sir? When you are making the combinations of your capacitor with resistor, లేదా inductor with resistor, లేదా all three of them, whatever the net resistance will be there, it will be called as impedance. గుర్తుపెట్టుకోండి. Okay, right. So you can simply say sir, this is your impedance లేదా this is your net resistance. అంతే కదా? Yes. ఇప్పుడు what will be the value of current sir? Same formula రా, I0 into sin of omega t plus, కానీ in case లో you understand, first is omega t, second is omega t plus pi by 2 కదా, the resultant will be somewhere between them రా. అదిగే omega t plus alpha. ఇప్పుడు ఈ alpha గురించి మాట్లాడాలంటే this alpha is equals to tan inverse of xc upon xr లేదా xc upon r. చాలు. So you can simply say sir, alpha is equals to tan inverse of 1 upon omega into c divided by r. If you are not understanding, just remember the formulas. ఎందుకంటే I'm not going into phasor diagrams and all. Okay, try to understand. Right. correct. So this will be the angle alpha. Alpha ante your tan inverse of 1 upon r into omega into c. ఇదిగో, this is the value of alpha. Okay, your I0 value చెప్పండి రా ఒక్కసారి. Your I0 is nothing but V0 upon impedance. ఇప్పటి నుంచి remember this formula. Your I0 is V0 upon impedance. Impedance అంటే the net resistance of the circuit. So RC circuit ఉంటే net impedance is root of R1 square plus R2 square. అదే కదా? Yes. So that means root of R1 square is R only రా, కానీ R2 square అంటే XL square, sorry XC square. ఇదే కదా? Yes. So that means root of R square plus 1 upon omega square c square. Substitute చేసుకోండి. Your I0 is nothing but V0 divided by root of R square plus 1 upon omega square c square. అర్థమైంది అందరికీ? Yes. So this is your RC circuits. ఇప్పుడు చూసుకోండి. If you want me to explain the phasor diagrams, I will explain that also. చూసుకోండి. మీ phasor diagrams లో for now you understand only this రా. చూసుకో. You have resistor, you have capacitor, and మీ దగ్గర inductor ఉంది. అదే కదా? Yes. So ఈ మూడు కోసం you take three different axes రా. Okay, if your voltage is equals to V0 into sine of omega t, we are assuming అందరికి sin V0 sine of omega t, we are assuming the phase differences రా. Phase difference అంటే we will be writing along the axis. చెప్పండి, for resistance what is the value of current రా? I0 into sine of omega t. అంటే phase difference ఎంత సార్? Zero. You represent that phase difference across x-axis. అంటే 0 కదా? Yes. So if phase difference is 0, all of you, if phase difference is 0, angle is 0. Angle 0 అంటే your line lies along x-axis only. If your angle is increasing అంటే it will go up, and if your angle is decreasing అంటే it will go down. But if it is 0 అంటే the line remains along your x-axis only. అర్థమైంది? Yes. Chapter will be completed by 11. Okay, 11 mostly. So this is for your resistor రా. చూసుకోండి అందరికి. ఇప్పుడు let us talk about your capacitor. చెప్పండి, for your capacitor what is the formula for current రా? I is equals to I0 into sine of omega t plus pi by 2 కదా? Yes. ఇప్పుడు చూడండి, the phase difference is more by pi by 2 అంటే angle is pi by 2. చూసుకోండి, increase it until pi by 2. అదే కదా? Yes. So this is your capacitor. అంటే ఇదే మీ XC కి వాల్యూ రా. యాంగిల్ అంటే ప్లస్ pi by 2. చూడండి, your current due to resistor and current due to capacitor, they have a difference of pi by 2. అదే కదా? Yes. And lastly you write about inductor also. Different color. Let us take red color. So ఇదే నా ఇండక్టర్ L ఉంటే your I value is nothing but I0 into sine of omega t minus pi by 2. అంటే your current due to inductor is lagging behind అంటే your angle is minus pi by 2. చూసుకోండి, minus pi by 2 అంటే in the clockwise direction. Okay, so your inductor will be somewhere around here అంటే XL రా. ఇదే XC, ఇదే R, ఇదే XL. This is a combination. Andariki jagrataga vinandi. Okay, if you want, I'll increase a little more thickness. Andariki. So this is my inductance. This. Okay, ide na XL value ra downwards kindaki. What about your XC value ra? It is in the upward direction, vertically upwards kada. Yes, so ide na XC value ra. And lastly, your resistance values gurinchi cheppandi okasari. This is your resistance value andariki. Now if you are good with the vectors, ra cheppandi. If you are good with the vectors, we are taking one by one kada. First circuit lo we talked about RC circuit kada. Ide na first vector, this is my second vector. Cheppandi 90 degrees kada. So two vectors aligned at 90 degree angles. Cheppandi, what is the resultant of them ra? Root of a1 square plus b1 square. Ade. So that's what I'm telling. Your impedance should be equals to root of xc squared plus r squared. Ade. For your RC circuit ra. You are understanding? What about your LR circuit? L ante inductance, R ante your resistance. Cheppandi. So in case lo kuda the same thing. Your impedance Z should be the root of this square plus this square ante XL squared plus R squared. Are you understanding this? Eppudu sometimes I need the angles also. Angles ante chuskondi. Ee angles kavali ra. This angle alpha for your capacitor kada. Resistance, capacitance. And here if you're talking about your net vector ra, net vector ide, this is my net vector ante na impedance ra. Andariki chuskondi. This is my impedance. Okay, this is my impedance. Where will it be ra? Between the two vectors. Ade kada. Yes, so if I'm talking about this angle, it is due to the inductor. Alpha due to inductor. Simple vectors ra, simple vectors format. Okay, are you understanding? If you have two perpendicular vectors, the resultant will be root a square plus b square. Okay, and what is the angle the resultant is making ante tan inverse of vertical upon horizontal. Cheppandi. So you shift this vector this side, this becomes your xc and this is your r. What is the formula for tan alpha? So tan alpha is vertical upon horizontal. Ide kada. So alpha is equals to tan inverse of xc upon r. Ikkada kuda the same thing ra. Cheppandi okasari your alpha value vertical ante xl, horizontal ante r. So here your tan alpha is xl upon r ante your alpha value is nothing but tan inverse of xl upon r. Can choose kondira. E alpha it is below x-axis, therefore alpha will be negative. Okay, alpha will be negative. Let us see one by one, all of you. So we talk about your LR circuit. Okay, LR circuit andariki cheppandi. Me LR circuit lo, in your LR circuit you do have current and you do have potential kada. Yes, so ide me potential ra, alternating current source, and this is your inductor and ide me resistor. Chuskondi. Inductor L, resistance R. Voltage V equals to V0 sin of omega into T. Idigo. Ippudu when you talk about current due to two independent apparatus ra, devices, two independent elements ra. So modatiga resistors gurinchi cheppandi ra. I is equals to I0 sin of omega T. Same phase untundi kada. Yes, resistance keeps the current in the same phase as your potential. Kani inductor ra, inductor gurinchi cheppandi. Your I is equals to I0 into sin of omega T minus pi by 2. It keeps behind ante your inductor decreases the current. Ippudu phase gurinchi chudandi ra. When you see about the first phase and the second phase is omega T ante something high. Second phase is omega T minus pi by 2. It has decreased. So the resultant will be somewhere in between them. Understanding? Yes. Modatiga you tell me about your I0 value ra. I0 is simply V0 upon R. Here your I0 is nothing but V0 upon omega into L. Ante your resistance is R. Here your resistance ante XL, that is omega into L. Idigo. First resistance, second resistance, net resistance entante you see the graph. This is your R value. Ide me XL value. Ide kada. Two vectors are there na. Add them. The resultant will be somewhere in between. Ante this value will be R square plus XL whole square ante R square plus omega square L square. Ide kada. Ippudu ee angle gurinchi cheppandi okkasari. you shift this vector that side, shift this vector shift it that side. Ade. Your vertical vector is nothing but omega into L. ఇప్పుడు యాంగిల్ గురించి చెప్పండి రా, tan alpha is nothing but opposite side అంటే ఏంటి రా, omega into L divided by adjacent side ఏంటి రా, resistance is R. అదే కానీ this is negative. Why negative sir? Because it is below x-axis. So negative ఉంటే your resultant equation లేదా your resultant current equation will be something like this. కానీ even before that చూడండి, this is your impedance కదా. Yes, చెప్పండి ఫార్ములా సార్. your I is equals to I naught into sin of omega t plus alpha రా. ఎక్కడ నుంచి I naught వాల్యూ చెప్పండి ఒకసారి. your I naught is nothing but your V naught divided by impedance. V naught upon Z sin of omega t plus alpha అంటే V naught divided by impedance value ఏంటిరా, root of R square plus omega square L square into sin of omega t. ఇప్పుడు మైనస్ రా. why minus? Because your resultant is making a negative angle with your x-axis. కాబట్టి నెగటివ్ సైన్ తీసుకున్నాం. అండ్ వాట్ అబౌట్ ద వాల్యూస్ ఆఫ్ tan alpha is that? అంటే alpha value, alpha value is nothing but tan inverse of omega into L upon R. ఇదిగో this is the current value, okay, in your LR circuits. చూసుకో. correct. Lastly, when you talk about your LC circuit రా, చూసుకోండి. మీ LC circuit లో you have the two things అంటే ఏంటిరా, first is your inductance and దాని తర్వాత you have your capacitor. ఇదే కదా. yes hey, and they are connected with an AC. They are connected with your AC. You able to understand? Yes. So in case lo what you will be saying is inductor is having inductance of L, your capacitance is equals to C. ఇదే కదా. yes. కానీ చూసుకోండి రా, they are opposite to one another. ఇదే కదా, they are opposite to one another. అంటే ఏమైతుంది సార్, if they are opposite to one another, ఈ కేసులో it will try to decrease the current, okay, and it will try to increase the current. చూసుకో. What about the impedance ra? Your impedance is simply equals to 1 upon omega C minus omega L. This is your impedance. Later you can also say omega L minus 1 upon omega into C. Whatever is greater, that will be taken as your impedance. Okay? Right. Correct. So this is your impedance. So what is the formula for your current? Sir, I naught into sin of omega t plus alpha. చూసుకోండి. Your I naught value ఏంటి రా? I naught is nothing but your V naught upon net impedance Z. Are you understanding? So this is your I naught value. అంటే your V naught divided by impedance value చెప్పండి ఒకసారి, 1 upon omega into C minus omega into L. This is your omega value. ఇప్పుడు చూడండి, what if XL అంటే omega L అంటే inductive reactance, XC అంటే 1 upon omega C, that is your capacitive reactance. అదే కదా. yes. If they are equal ra, అంటే ఏంటి రా, your XL is equals to your XC అంటే omega L is equals to 1 upon omega into C. That means your omega should be equals to root upon 1 upon LC. Simplify చేసుకోండి. This is your omega. If they are equal అంటే ఏంటి రా, if they are equal, that means the net resistance లేదా impedance కదా. yes. Your impedance is equals to 0. That means you have no resistance in the circuit at all. You are understanding? అంటే that means your circuit simply behaves as a linear wire. Finished. I hope it is understandable to you. Okay. And lastly, let us talk about the combination of all of them together. All of them together ante enti ra? You have your inductor, capacitor and resistor connected across a series. Ade kada? yes. So that means this is your inductor, ide your capacitor and this is your resistor. They are connected in series ra chuskondi. The source is same AC source. You are saying yes, so your voltage V is changing as following, V naught into sine of omega into T. Inductance is L, capacitance is C, resistance is R. Andariki chudandi. So these are the components of the circuits. Ide kada? Yes. ఇప్పుడు మళ్ళీ ఒకసారి if you want to draw the graphs, you can draw the graphs also. చూసుకోండి, ఇదే your resistance along the x-axis, your capacitance along positive y-axis అంటే xc, and your inductance along negative y-axis అంటే xl రా. చూసుకోండి, you treat these three as a vectors. అర్థమైంది? Vectors అంటే your resistance along I cap and these two along your j cap. So how will you find the resultant రా? చెప్పండి. So what you do is, sir, first of all let us try to find the resultant of vertical things. Vertical things ante enti ra? Ide xc, idi xl, ade kada. What will be the resultant ra? If xc is greater than xl, andariki, if your xc is greater than xl ante the graph looks something like this. Chusko, if xc is greater than xl, where should I draw it ra? Okay, let us say it's here. Okay, the first case lo your xc is greater than xl. So if xc is greater than xl, what happens is, చెప్పండి అందరికి, what will happen ra? The resultant looks something like this. చూసుకోండి, ఇదే మీ resistance R, కానీ vertical లో you will be having xc side కదా. Yes, so this becomes your xc minus xr రా. ఇదిగో 3 నుంచి 2లో కన్వర్ట్ అయింది కదా. Yes, here also in your second case, చెప్పండి, మీ second case లో what happens is, tell me all of you, if your xl is greater than xc అంటే it is more, it is less, so that means the resultant will be towards the more side downwards. చూసుకోండి, so your graphs do simplify like this ra. This is your resistance R and this becomes your XL minus XC. కానీ చూసుకోండి, ఈ రెండు కేసెస్ లో కూడా the resistance R remains unaffected ra. Vectors re, vectors, okay, simply vectors. Okay, simply vectors andariki. So these are the vectors. చూసుకోండి, what about the resultant ra? Resultant will be between them. అదే కదా. Yes, so first let us talk about this resultant ra. చెప్పండి, your resultant అంటే impedance is root of x-axis squared plus y-axis squared. X-axis squared అంటే simply r squared plus xc minus xr whole square. ఇదే కదా. Yes, యాంగిల్ చెప్పండి రా ఒకసారి. యాంగిల్ ఆల్ఫా ఉంటే this alpha is nothing but, లేదా tan alpha is nothing but vertical side ఏంటి రా? xc minus xr divided by horizontal side is r only. ఇక్కడ చూడండి, this is your first vector, this is your second vector, ante the resultant will be between them. అదే కదా. Yes, the resultant will be between them. చెప్పండి, వాల్యూ అంటే ఇంపెడెన్స్ z root of horizontal squared plus vertical squared. అదే కదా, root of r squared plus xl minus xc whole squared రా. What about angle alpha రా? Your alpha is nothing but tan inverse of vertical upon horizontal. చెప్పండి, అంటే ఈ కేసులో your tan alpha is equals to, what is vertical side ra? xl minus xc divided by r. కానీ this alpha is negative kada. Negative. Why? Because sir, it is below x-axis. కాబట్టి ఈ కేసులో you should be writing a negative alpha. Here you should be writing positive alpha. You're understanding? Try to understand, all of you. అంటే you have two cases. The first case is if your xc is greater than xl అంటే your capacitance dominates. Capacitance dominates అంటే capacitance try to increase the current. You are understanding? Capacitance tries to increase the current. So if capacitance is dominating, అంటే the current will be increasing. అదే కదా. Yes, ఫార్ములా చెప్పండి రా ఒకసారి. Your current I should be equals to I naught into sine of omega t. Current should increase kada. Yes, కాబట్టి angle alpha. ఇదిగో, try to understand. I don't know yaar what's happening with this. 1 2 3 4 5. Good, 5 seconds. And my second case lo, if your XL is greater than XC ante your current will lag. Why, sir? Because the inductor is stronger and inductor lags the current. ఈ కేసులో your current leads రా, ఇదే కదా? Yes, ఈ కేసులో your current is leading అంటే your capacitance is more strong than inductor. If the capacitor is more strong, it will try to increase the current. ఇదే కదా? Yes, good. So what is the value of I0 రా? ఈ మొత్తం కేసెస్ లో your I0 value is V0 upon impedance. ఇక్కడ కూడా your I0 value is nothing but V0 upon impedance Z. ఇప్పుడు impedance value changes, not changes, right? It's root కదా? Yes, so impedance value is root of R squared plus omega L minus 1 upon omega C whole squared రా. ఇక్కడ కూడా you can write the same thing, that is nothing but your V0 divided by root of your resistance squared plus omega L minus 1 upon omega C whole squared. చూసుకోండి, ఈ రెండు సినారియోస్ లో కూడా your value of the peak current remains the same, కానీ your alpha changes రా. చూసుకోండి, ఈ కేస్ లో current leads కదా, so your I should be equals to I0 sin of omega t plus alpha. ఎందుకంటే the capacitor is dominating, capacitor increases the current, so current increased by angle alpha. ఎక్కడ వచ్చి your inductance dominates and inductor decreases the current, so your I should be I0 into sine of omega t minus alpha. When I say decreases the current, it decreases with respect to potential. గుర్తుపెట్టుకోండి, ఈ రెండు కేసెస్ కోసం కూడా your potential is same రా. Your potential is V equals to V0 sine of omega into t. You try to see here, your potential here V is equals to V0 sine of omega into t. చూసుకోండి, ఇప్పుడు ఈ potential ని it will try to increase what? Capacitor. What increase? Current increase. That means if your capacitor is strong, it will increase the current from potential ra, ante it will try to keep the current value more than your potential value. If your inductor is strong, it will try to decrease the current value than your potential value. చూసుకోండి, you are understanding? Yes. So you try to understand, ఈ కేసులో మీ alpha value ఏంటంటే you can simply say, sir, I is equals to I0 sine of, లేదా directly let us write the value of alpha. What did we say? Alpha is nothing but tan inverse of, చెప్పండి, 1 upon omega c minus omega L, vertical side completed kada, divided by horizontal side is R only ra. Direct substitute చేసుకో, your current value is I0 into sine of omega t plus tan inverse of 1 upon omega c minus omega L whole divided by R. ఇదిగో, this is the value of the current in your series LCR. అదే కూడా when your capacitance dominates the inductance. You are understanding? Yes. What about the reverse? Reverse case lo your inductor is more, your capacitor is less. ఆ కేసులో your value changes a bit, అంటే your I should be equals to I0 sine of omega t minus alpha value ఏంటిరా, tan inverse of 1 upon omega L minus omega c divided by R. Try to understand. Okay, right. So these are the values of current for your LCR circuits. You are understanding? Yes. Try to understand. Okay, correct. Malli okasari the same thing I am writing. Okay, that means for your omega is equals to omega naught, ante value is 1 upon root of L into C. Your inductive reactance is equals to capacitive reactance, ante ee renduni they will cancel out one another. That means your three elements, me inductance, then your resistance, and then your capacitance kada. Yes, ఈ మూడు నుంచి the two they will cancel out one another. Two అంటే ఏంటిరా, your inductor will cancel out your capacitor, అంటే you are only left with a resistor into your circuit. ఆ కేసులో your current should simply be equals to I naught into sine of omega t. కానీ ఈ కేసులో your I naught is equals to V naught upon R రా ఇదిగో. And your alpha also gets equal to 0. అంతే కదా? Yes. So this is a condition for your resonance. You're understanding resonance ante your resonance frequency f should be equals to 1 upon 2 pi root of L into C. Idigo. So when your frequency ante frequency of rotation of the loop. What loop ra? The loop that we kept in the external magnetic field gurdunda, due to which this voltage was coming ra, that loop's frequency should be 1 upon 2 pi root LC. Then and only then your inductor and capacitor will cancel out one another until you will simply get your resistance. And this is how your circuit gets simplified. We are done talking about your LC circuit, your LR circuit, your LCR circuit, and your RC circuit also. So 4 types of circuits have been completed. Ippudu we will be talking something about your power. Okay, power gurinchi chuddam andariki. So when we are talking about your power in your AC circuits, power is simply equals to V into I. Ade kada leda I square into R, whatever you want to write you can write it. Chuskondira, your power P is equals to V into I. Ade kada? Yes. V ante entira? Voltage. What is the value of voltage ra? Every case, in each and every case, whether it's simple pure resistive, pure capacitive, leda RC, leda RL, leda LC, leda LCR. For each and every circuit ra, the value of your voltage remains the same, V naught sine of omega into T. Idigo. Kani me I value changes, ade kada? So if it's a pure capacitive, I value changes to I naught sine omega T plus pi by 2. Inductive circuit unte minus pi by 2, combination unte plus alpha. You're understanding? Kani it will be changed. So in case lo I am simply assuming your I value is nothing but I naught into sine of omega T plus phi ra. Phi ante enti ra? It is the resultant phase depending upon the conditions. LC circuit unte your phi will be tan inverse of 1 upon omega L minus omega C. Understanding? If it's an RC circuit unte tan inverse of 1 upon omega C divided by R. LR circuit unte tan inverse of omega L divided by R. Try to understand. LCR circuit unte tan inverse of root of all of that. Okay, tan inverse of omega L minus 1 upon omega C divided by R. Depending upon the situation, whatever it is, I'm not concerned. Okay, I'm not concerned about it. Just go. ఇప్పుడు I have to talk about power. చెప్పండి, power is equals to V into I. ఇదే కదా, V value ఏంటిరా? V naught sine of omega into D. I value ఏంటిరా? Your I value is I naught into sine of omega D plus phi. ఇది you're understanding? ఇప్పుడు let us try to expand it. Okay, let us try to expand it అందరికి. So we can simply say your values are something like this. మీ power value అంటే V naught into sine of omega t multiplied by I naught into, ఇప్పుడు sine of a plus b కదా? Yes, so it simplifies as sine a cos b plus cos a sine b. Very good. చూసుకోండిరా. Try to understand all of you. Okay, now what it is, we multiply this with this, we multiply this with that. చూసుకోండి. అంటే it comes out to be V naught I naught. మొదటిగా కాన్స్టెంట్ ని మల్టిప్లై చేసుకోండిరా. సో ఇట్ ఈస్ V naught into I naught. చూసుకో, sin omega t into sin omega t అంటే sin square omega t ఇదే కదా? Yes. So it is sin square omega t. What is remaining ra? Cos phi. Correct. Plus multiply this with that ra. సో కాన్స్టెంట్ అంటే ఇక్కడ V0 అండ్ హియర్ ఇస్ I0 రా. మళ్ళీ ఒక్కసారి V0 ఇంటూ I0 మల్టిప్లైడ్ బై చెప్పండి sin omega t cos omega t sin phi. So your sin omega t into cos omega t into sin phi. అదే. సో దిస్ ఈజ్ యువర్ పవర్ టర్మ్ రా. ఈ ఎక్స్ప్రెషన్లో 3 టర్మినాలజీస్ ఉన్నాయి. సో దిస్ ఈజ్ యువర్ ఫస్ట్ టర్మినాలజీ, ఇదంటే మీ సెకండ్ టర్మినాలజీ, అంతే కదా? ఎస్. ఇప్పుడు చూడండి అందరికీ, ఓకే, ట్రై టు అండర్స్టాండ్ వెన్ వి టాక్ అబౌట్ యువర్ యావరేజ్ పవర్ రా. అందరికీ మళ్ళీ ఒకసారి రాసుకోండి, చూసుకోండి పవర్కి ఎక్స్ప్రెషన్. సో యువర్ పవర్ సింప్లీ ఈక్వల్స్ టు V0 ఇంటూ I0 ఇంటూ సైన్ స్క్వేర్ ఒమేగా టీ ఇంటూ కాస్ ఫై. ఇస్ ఇట్ విజిబుల్ రా? ఎస్. Plus it is V0 into I0 into sine of omega t cos of omega t into sine of phi. These are the two terminologies in your power expressions. Can you choose kondi? When we talk about your average power andariki mee average power gurinchi maatladalante you take the average value of each of the expressions kada. Yes, that means you take the average value of your sine square. At the same time, you take the average values of both of this. Can you choose kondira? In the beginning of the chapter itself, I've told you that the average power of sine and average values of sine and cos are 0. Ante average becomes 0 ra. A term and it's gone completely. What about your sine square ra? Your sine square average is half. I've told you in the beginning of the lecture ra. Chuskondi. Ante your power average becomes ee mottam ki place lo you write half. You are left with V0. You are left with I0 into cos phi. Ardhamaindi andariki. So these are your power formula ra. Ekkad nunchi you can simply say, sir, your average power is nothing but, I will try to rewrite it ra. Ide 1/2 kada? Yes. So let us try to write it as 1/√2 into 1/√2 into V0 into I0 into cos phi. Hey, cos phi. Eppudu club ra, club ante merge them together. E 1/√2 into V0 and E 1/√2 into I0. Ante you can simply say, sir, I0 upon √2 multiplied by V0 upon √2 multiplied by cos of phi ra. I0 upon √2 ante IRMS. IRMS kada? Yes. Your I0 into √2 is simply IRMS. What about your V0 into √2 ra? Idi kuda VRMS ra multiplied by your cos phi. ఇప్పుడు చూడండి ఈ cos phi అంటే ఇట్స్ అ ఫ్యాక్టర్ కదా, ఇట్స్ డిసైడింగ్ హౌ మచ్ పవర్ విల్ బి దేర్. ఈ cos phi కి వాల్యూ మాక్సిమం అంటే 1. ఈ cos phi కి వాల్యూ 1 ఉంటే యువర్ పవర్ విల్ బి మాక్సిమం రా. చూసుకోండి, దిస్ ఈజ్ యువర్ యావరేజ్ పవర్, అంతే కదా? ఎస్. సో ఈ cos phi ఇట్ ఈస్ నోన్ యాజ్ యువర్ పవర్ ఫ్యాక్టర్. phi అంటే ఏంటి సార్? This phi actually came from your current ra. Chuskondi, your voltage was V0 sin omega t. Kani your I has this extra term phi kada. So what is this value of phi ra? It depends on the circuits. Understanding circuits. Yes. And if your circuit is pure capacitive, and your phi value is equals to plus pi by 2. Wait, not minus pi by 2, right? It should be plus pi by 2 only, okay? If pure capacitive unte plus pi by 2. Leda, if your circuit is pure inductive ra. Hey, chuskondi. If your circuit is pure inductive andariki, your circuit is pure inductive circuit unte your phi value should be equals to minus pi by 2. Ide kada? Yes. What about your circuit is RC circuit? That means your phi value is nothing but tan inverse of 1 upon omega c divided by r ra. Current values chudandi ra. Ee mottam cases lo whatever we have found the current value, same values, okay? Same values. Ekkada kuda if it is LC circuit cheppandi, LC circuit unte mee phi value is nothing but tan inverse of omega L upon r. లేదా if it's a combination of LCR circuit, what is the phi value? Phi value is equals to tan inverse of, చెప్పండి, it is nothing but omega L minus 1 upon omega C divided by R ra. These are the values of your phi for different circuits. Okay, so ante your power factor varies or power factor is different for different circuits. Let us take one by one case. Chooskondi. Your first is pure capacitive circuit. Chooskondi andariki. Your pure capacitive circuit lo, what is the value of voltage andariki? It's again a revision for you also. Voltage is simply equals to V naught sine of omega t. Current value is I naught sine of omega t plus pi by 2. ఈ కేసులో your phi value is equals to pi by 2 అందరికి అంతే కదా. yes, so this is your phi value. చూసుకోండి. hey, not this ra, I'm sorry. Okay, this is not the phi value అందరికి చూసుకోండి. this is not the phi value ra. now what will be, yes, pure, correct, this is your phi value, I'm sorry, pi by 2 అదే. so your pure capacitive circuit, in your pure capacitive circuit, this is your phi value. What about your pure inductive circuit ra? Cheppandi okkasari. If your circuit is pure inductive, ee pure inductive circuit lo cheppandi what is the value ra? What is the value andariki? You can simply say, sir, potential V equals to V naught into sine of omega t, and at the same time your current is equals to I naught into sine of omega t minus pi by 2. ఈ కేసులో your phi value becomes minus pi by 2 అందరికి. okay, try to understand. This are the values of phi ante initial phase difference. ఇదే కదా. yes, what if you are doing combinations ante your RC circuit and at the same time your LR circuits. Quickly I'm talking about these two only ra. చూసుకోండి. మీ RC circuit లో this is your resistance, this is your capacitance, this is your sources. అంటే ఇదే your potential V equals to V naught sine of omega t. resistance or capacitance C unte, you can simply say value of current I naught into sine of omega t plus alpha ra. ఈ alpha ante it becomes your phi. now ఈ కేసులో your power factor, I'm talking about your power factor terminology ra, cos phi ఉంటుంది కదా. yes, so ఈ కేసులో your phi is equals to alpha, that is equals to tan inverse of vertical side ra. vertical side is 1 upon omega c. చూసుకోండి, 1 upon omega c divided by resistance R. ఇదిగో. so if this is tan, you can calculate the value of cos substituted. okay, yes, and lastly we'll talk about your LR circuits. చెప్పండి అందరికి. మీ LR circuits లో this is your inductance, ఇదే అంటే నా resistance, this are connected to an AC source ra. voltage V equals to V naught into sine of omega into T, inductance L, resistance R andariki. what is the value of current ra? your I naught into sine of omega T minus alpha enduku sir? because your inductor current decreases. okay, inductor decreases the current. understanding? yes, that means in case low your phi value is negative alpha. what is the value of alpha ra? case low alpha is tan inverse of omega L upon R andariki. I am writing these things twice thrice endukante I want all of you to be very good with these formulas. okay, right. and lastly when you talk about your LCR circuits ra, chudandi, if you are talking about your LCR circuits, ante you have an inductor, you have a capacitor, you have a resistor. అదే కదా. yes, and this is your AC source అందరికి. చూడండి, inductor, capacitor, resistor. ఈ కేసులో your voltage value remains the same ra. అంటే V naught into sine of omega into T. what about current value ra? it should be I naught into sine of omega T plus alpha. ఈ alpha is nothing but tan inverse of, it has two different cases. okay, it has two different cases రా. ఈ alpha కోసం you are having two different cases. అంటే if your xc is greater than xl లేదా your xl is greater than xc, your alpha is nothing but minus tan inverse of omega l minus 1 upon omega c divided by r. Here your alpha is nothing but tan inverse of 1 upon omega c minus omega l divided by r. Idigo, these are two different cases. And this itself is your phi ra. Andariki, this is your phi. Ante power factor cos phi lo, this is the value of phi. Ante kada? Yes. Okay, correct. Sorry, so we are done talking about your power factors. If you want, you can take a PYQ also. I think there is a PYQ based on this thing. Okay, చూద్దాం అందరికి. What is the PYQ? తీసుకోండి. సో ఈ క్వశ్చన్ సాల్వ్ చేయడానికి యూ హ్యావ్ టు అండర్స్టాండ్ అబౌట్ దిస్ రా. చూసుకోండి అంటే ఏంటి, if you have all circuits together, all circuits into తెలుసా, what is this value of omega c ra? Omega c is xc. xc అంటే capacitive reactance కదా. Yes. What is the value of omega l ra? Your omega l is nothing but xl అంటే inductive reactance అదే కదా. Yes. So I'll simply write this. చూసుకోండి LCR circuit ఉంటే I'm writing this. You can modify the same in other circuits also. Okay. చూసుకోండి అంటే your alpha is nothing but tan inverse of something. Now let us say tan inverse of a by b రా. చూసుకోండి అంటే your tan alpha is equals to a upon b కదా. Yes. ఇక్కడ నుంచి you have to find the value of cos alpha. Cos alpha అంటే your power factor. Cos alpha and tan alpha they are related రా. How are they related అంటే I'll quickly tell you the relationship. చూసుకోండి if tan alpha is a by b, you simply take the denominator of tan, okay, and take the square root of squares of sum of both of them అంటే a square plus b square. This is a relationship. Tan to cos switching ఎలా చేయాలి సార్, take the numerator, take the denominator of tan in the numerator and in the denominator put the squares. అంటే I'll tell you simply, చూసుకోండి if you have tan inverse of 2 by 3, how will you do that? It is nothing but cos inverse of, take the denominator in the numerator, root of square them 4 plus 9 ఇదే కదా. Yes. అంటే it is nothing but cos inverse of 3 upon root 30. Try to understand. This is very important, okay? Whatever is there in the denominator, take it up, and in the denominator you take the squares of them. అదే మళ్ళీ ఒకసారి if you are saying tan inverse of p upon q is nothing but cos inverse of, take the denominator q divided by, take the squares of both of them రా, p square plus q square. అదే try to understand this. Same here also do the same thing రా. ఎక్కడ కూడా the same thing. చూసుకోండి hey where is it కదా. Yes. tan inverse of denominator ఏముంటుంది రా, so it is nothing but cos inverse of చెప్పండి r divided by root of this square plus that square అంటే మొత్తం 1 upon omega c minus omega l whole square plus r square. This is the formula for phi. Phi అంటే cos inverse, లేదా you can simply say cos phi is equals to చెప్పండి r upon root of 1 upon omega c minus omega l whole square plus r square. ఇదిగో this is a formula. ఇక్కడ నుంచి you can do it by yourself. Okay, try to understand. Okay, right. Here do the same thing. Same thing అంటే ఏంటిరా, your cos phi should be equals to చెప్పండి what should it be రా, it should be r upon root of omega l minus 1 upon omega c whole square plus r square. ఇదే కదా. This is the actual formula అందరికి. Okay, this is the actual formula. This is the actual formula. కానీ you can do one thing. Okay, you can do one thing. Your cos phi is equals to multiply numerator and denominator by I naught. I naught అంటే ఏంటిరా, I naught అంటే the peak value of the current in the circuit. అదే కదా. Yes. So it becomes I naught into R divided by root of చెప్పండి what is it రా, what is it sir, it simply converts into I naught omega L minus I naught divided by omega into C. ఇదే కదా. Yes. Plus I naught into R whole square. Square plus square కదా. Try to understand. ఎప్పుడు I naught into R అంటే voltage across resistor. Yes, I naught into R అంటే voltage across resistor divided by root of, ఇప్పుడు చెప్పండి ఒకసారి I naught into omega L అంటే voltage across inductor. Yes. What is bigger రా, across resistance, capacitance and inductor కదా. Yes. So capacitance, inductor అంటే inductor is more. అదే the same thing. Your VL minus this becomes potential across capacitor అంటే VC whole square plus మళ్ళీ ఒకసారి I naught into R అంటే potential across resistor whole square. చూసుకోండి. Done. చెప్పండి రా, across resistor ఎంత రా, 80 divided by root of VL value ఎంత సార్, 100 కదా. Yes. So 100 minus 40 whole square plus చెప్పండి plus your resistance రా, resistance ఎంత సార్, resistance is simply equals to 80 కదా. Yes. So 80 whole square అందరికి. It's very simple now. So your cos phi is equals to 80 divided by directly రాస్తున్నాం 100 minus 40 అంటే 60. 60 square plus 80 square. Standard Pythagoras triplets రా. Pythagoras triplets. Directly 100 value వస్తుంది. Okay. 80 divided by 100 అంటే your value is 0.8. గుర్తుపెట్టుకోండి. Try to understand. Okay. కానీ the formula for cos phi remains same. R upon root of 1 upon omega L minus 1 upon omega C whole square plus R square. Understanding? Yes. Okay, right. Chappandra. Okay, right. Correct. Now let us talk something about your transformers. This is the last topic of your chapter. Transformers. చూసుకోండి ట్రాన్స్ఫార్మర్స్ అంటే ఏంటిరా ట్రాన్స్ఫార్మర్స్ ఆర్ సింప్లీ ద డివైసెస్ దట్ చేంజ్ ద పొటెన్షియల్ ఫ్రమ్ వన్ వాల్యూ టు అనదర్ రా చూసుకోండి ఏమైతుంది అంటే ఇఫ్ యూ వాంట్ టు కండక్ట్ ద కరెంట్ లేదా ఇఫ్ యూ వాంట్ టు కండక్ట్ ద ఎలక్ట్రిసిటీ you will have to conduct it at low potentials ra chuskondi it is just as if I'm giving you an example okay jagrataga vinandi okay try to understand ra this is first mobile okay ide first mobile this is the second mobile kada yes this is the second mobile ra chuskondi ippudu they do want to call one another so emaitidi ante this mobile will send your audio hello your audio kada it is sending into signals first thing that's happening is your audio is getting converted into signal ra chuskondi ide kada yes ippudu this signal is transferred andariki chuskondi this signal is transferred dan tarvata the same signal is received malli okkasari this is converted from signal to audio and you listen the same sound try to understand first conversion second conversion ade kada the same thing ante entira if this is your power station A okay it is your power station A ra andariki chuskondi this is your power station A and this is your power station B all of you try to understand okay ide me power station B ra what happens ante you have to conduct the electricity leda you have to send electricity from one place to another kada you have to send it mari when you are sending your voltage should be low enduku sir because in the meanwhile leda in the midway or anything can happen sir any accident can happen some wires can break are you understanding some loss of energy can happen kabatti what we have to do is we have to convert it from a higher potential chuskondi ra modatiga we are converting your electricity from higher potential to lower potential ade and this lower potential current is actually traveling through these wires once the traveling has been completed malli okkasari this lower potential will be converted to higher potential again ra andariki chuskondi this is how the process flow works you are understanding try to understand okay right ante your high power is getting converted into low power that low power is transferring once the transfer has been completed malli okkasari your low power is converting into high power ide kada yes this is something so ippudu when you want to study about the conversion from high voltage to low voltage leda higher potential to lower potential and vice versa lower to higher also we use transformers understanding why to use transformers because we have to change the potential values higher to lower lower to higher vice versa try to understand okay with that being said chuskondi the construction of a transformer construction of a transformer begins with a soft iron core. I'm telling you, soft iron core kada? Yes. Malli okasari let us take the same thing. Ante so this is your soft iron core. Ante kada? What we do now is we actually wind up some wires ra. Chusko. So ide na wire, it is coming and getting winded up, something like this. Right. Chuskondi. This is a set of your wires, not hands ra, not leg ra. It's a wire, okay? Combination of wire. Here also, what you're doing is you are connecting some wires. Okay? You are winding some wires ra andariki. 3, 4, 5, 6, 7, 8. Are you understanding? Yes. For sure, you can understand that there are N1 turns. N1 turns choose 1, 2, 3, 4, 5, 6, 7 turns are there. Here there are 8 turns. Okay. In case you have N2 turns. Try to understand. When you are connecting this with AC ra andariki. So if it's an AC source, try to understand. Okay, if it's an AC source, hey, what's happening ra? If this is an AC source andariki, what's happening is your current is continuously changing kada? For sure. Yes. Current is changing ra. Let us go step by step. What's happening, sir? First step is your current changes. Ide kada? Yes, your current is changed. Daan tarvata there will be a flux generated. Ide kada? Yes, there will be a flux generated. Ippudu whatever flux is generated, it will try to give rise to a magnetic field. Yes. That means induction of magnetic field happens ra. Are you understanding? Induction of your magnetic field B bar ra. Ante this loop will have some magnetic field generated. In mottam magnetic fields, they are traveling from one loop to another. Okay, yes, ante your entire change in the magnetic field has been transferred to the other place also. Ide kada? Yes. So this is the magnetic field. Enduku sir? Because this is a soft iron core. Iron core unte it's a ferromagnetic substance. Chusko. Ferromagnetic substances ante they are attracted లేదా they absorb the magnetic fields completely. So entire magnetic field has been transferred to the second loop ra. చూసుకో ఇప్పుడు ఈ సెకండ్ లూప్ లో వచ్చిన తర్వాత you can simply say that in second loop your magnetic field is changing and varying with time kada. Yes, your magnetic field is varying with time ra andariki. Your magnetic field is varying with time. Malli emaitadi sir? If your magnetic field is varying ante it will give rise to current. చూసుకోండి రా. You are understanding? Ante you change the current here, automatically there will be a fluctuation of the current in the second loop also. ఈ మొత్తం సెటప్ ని we will be calling it as our transformers. ఇప్పుడు చూసుకోండి రా అందరికి. ఓకే, ద ఈఎంఎఫ్. ఇప్పుడు ఈఎంఎఫ్ గురించి మాట్లాడుతాం. చూసుకోండి అందరికి. ఈఎంఎఫ్ అంటే E1 E2 అదే కదా. ఎస్, E1 E2 E1 E2 E1 E2. హియర్ ఈఎంఎఫ్ ఇస్ E1, ఎక్కడ వచ్చి ఈఎంఎఫ్ ఇస్ E2 రా అందరికి. చూసుకోండి. ఇప్పుడు let us talk something about the transformers formula అందరికి. This is your transformers formula. అంటే your EMF E1 divided by your EMF E2 is equals to n1 divided by n2. n1 n2 అంటే ఏంటిరా? Number of turns in your primary and your secondary coil. Primary coil అంటే this రా, చూసుకోండి. This is your primary coil, okay? ఇదే. And this is your secondary coil. అందరికి. First is your primary coil, then second is your secondary coil. n1 అంటే ఏంటిరా? n1 అంటే simply number of turns in primary coil. ఇదే కదా? This is known as number of turns in your secondary coil. చూసుకో. Try to understand. Terminologies చాలా important. Okay, with that being said, try to understand now, okay? The first case is if the value of n1 is greater than n2. అంటే ఏంటిరా? This. If the value of n1 is greater than n2. n1 greater than n2 అంటే ఏంటి sir? That means you're simply saying that, try to understand, it should be something like this. Again, something like this. Just. So this is the value of n1 ra, andariki. So this is your first number of loops. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the value of n1. Kani, your n2 values are something like this. 1, 2, 3, 4. Ide. Understanding ante n1 is greater than n2. In case lo, this is your n1, this is your n2. What happens ra? Ante you are having n1 greater than n2 ante your EMF will be greater than E2 ra. Same thing, n1 greater than n2 and E1 greater than E2. That means your EMF E1 was here ra. Malli if you see the EMF here, it is less. Ante EMF has reduced ante down. That means this transformer is known as your step down transformer. Understand? Try to understand. Why is it used, Ra? It is used, cheppu okkasari. It is used to reduce the voltage from primary to secondary coil. Ide kada? Yes. From primary to secondary coil. This is known as step down transformer. Try to understand. Once again, when you're talking about the opposite ante enti ra? If your n2 is greater than n1, malli same thing ra, E2 will be greater than E1. E2, E1 ante EMF2, EMF1. Idigo. So this is your n primary coil. Ide ante me secondary coil ra. Shifted exactly in the middle. Okay. Whatever. First, second, third, fourth. Finished. And here is your n2 value. Choose 1, 2, 3, 4, 5, 6, 7, 8, 9. Try to understand. Okay. And your n1 value is less than n2. Mari emaitidi ra? Your EMF increases ra. So if you have 10 volt here, it will get converted to 20 volts. Understanding? EMF increases. All of you. EMF increases. Ante EMF increased. Ante EMF value increase ante up. Kabatti the name is step up transformer. ఇదే కదా? So these are the values. చూసుకో. ఇప్పుడు what is an ideal transformer రా? చూసుకో. The ideal transformer అంటే in your ideal transformer energy should be conserved. ఇదే కదా? Your energy should be remaining the same. అంటే your energy should be conserved. Energy should be conserved. It is not possible, not possible. practically energy cannot be conserved. There will 100% be the loss of energy for sure. Kani we will take the care, leda we will try our best to keep the energy loss minimum and telsa. We will have to keep the energy loss very low. So in what form the energy is lost, sir? In what form the energy is lost, sir? Ante energy is lost in two different forms. Chuskondi. Energy is lost in number one, heat kada? Yes, heat in coils. And number two, eddy current forms eddy current. Magnetic field is flowing kada through the soft iron core. Magnetic field goes, well, there will be some eddy currents generated, and these eddy currents will be consuming some energy. You are understanding? If at all you are taking the low resistance coils, your energy loss will be minimum. Yes. And at the same time, if you are taking soft core, your energy loss will be minimum. Ade kada kabatti, yes, this is live ra. Obviously this is live. Who is telling this is not live ra? Huh? Sorry. Okay, so with that being said, our chapter has been completed. చూసుకో, ఏదైనా డౌట్స్ ఉంటే చెప్పండి, or else we will be concluding the session. Yes. Hi. Anuja, hi, good evening. Yes, power factor ante cos phi. For maximum power, cos phi should be 1. Cos phi should be 1 ante enti, or phi should be 0. Ade. So that's what I'm telling to you. If you have your omega, leda your omega value, if your omega value is equals to 1 upon root of L into C, this is the condition for the maximum power output. Understanding? Yes. That is the condition for your maximum power. E condition low, when your omega ante 2 pi f, ante enti ra, your frequency f. If your frequency is 1 upon 2 pi root of L into C, ade, in that case your power is maximum. Understanding? Yes. Sorry. Okay, everybody, if you don't have any doubts, can we stop this session and what and yes, చెప్పండి, what's your doubts? What are the doubts? చెప్పండి ఒకసారి. Let us quickly go through your doubts and let us clear it. No doubts లేదంటే you may leave the sessions. Yes. There is a wave optics tomorrow. Okay, so tomorrow we'll be completing your entire wave optics from the scratch itself. Once your wave optics has been completed, ante your electrodynamics completed, full short your electrodynamics has been completed, right from your capacitors, not capacitor, electrostatics. మీ ఎలక్ట్రోస్టాటిక్స్ నుంచి ఫైనల్ చాప్టర్ అంటే మీ అల్టర్నేటింగ్ కరెంట్ వరకు మొత్తం చాప్టర్స్ హ్యావ్ బీన్ కంప్లీటెడ్. ఓకే, ఒకటే చాప్టర్ మీ మెకానిక్స్లో there is a single chapter left, properties of fluids. ఒకసారి that chapter also completed, that means your mechanics, your electrodynamics, your geometrical optics completed. రేపు one more branch of you అంటే your SHM and waves, that will be completed. So there will only be two branches left ra. First is your heat thermal physics and దాని తర్వాత your modern physics. అదే thermal physics, modern physics completed అంటే your entire physics syllabus will be completed. Okay, and దాని తర్వాత we will be talking about your PYQs only. So we will take the marathons that only insist లేదా that only include your PYQs and also your IPE sessions. Okay, your IPE sessions, they are also be going to get scheduled soon andariki. So we will be having some predicted papers also, one shot series also. Okay, so it will be scheduled soon andariki. చెప్పండి, ఏదైనా డౌట్స్ ఉంటే చెప్పండి, లేదంటే యూ మే లీవ్ ద క్లాస్. కరెక్ట్. ఒక్కసారి లైక్ చేసుకోండిరా వీడియో లైక్ ఇట్. ఓకే, వీడియోని లైక్ చేసుకోండి బికాస్ ఐఎమ్ సీయింగ్ దాట్ ద నెంబర్ ఆఫ్ వ్యూస్ ఇస్ నాట్ మ్యాచింగ్ ద నెంబర్ ఆఫ్ లైక్స్. సరే, bye 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 bye. Okay, good night everybody. Good night. Take care. Bye bye. Bye all of you. Bye.